Good evening, y'all. Why are we muted? Why? Oh, no, we're not. Oh, we're not muted for a change. Everything's working. Hi, good evening. Welcome back to another Sunday night where we talk about mini moving lights and 3D printing and PCBs and other nerdy stuff. I'm Jeff. It's good to be here again on a lovely Sunday night. It's been a big week. I finally finished putting together the documentation on building your own Demilight for those who are interested in doing so. And obviously not a final thing, but a thing you can do if you want to. And so tonight I'm going to go through like the build instructions for one of these things that I've been working on for just so long. And that's just going to feel, I think, really quite good. So I'm excited to do that with y'all. It was also a big week. One of my projects got picked up by surprise on Hackaday yesterday. One of the add an indicator to the 3D printer project that I did so long ago. So there may be some people here who are watching tonight who are hear from that, which would be kind of fun. But other than that, we're just gonna kind of vamp and go through what it means to build a little tiny moving light. Woo times two, says Chris. Hi, Chris. Good to see you. Yeah, we'll have a good old time tonight. It has it's been I should know this, right? But creating documentation of something always takes at least twice as long as actually doing the thing. So the process of writing the documentation for the tiny movement for the Demilight it's been a process, y'all. I started basically 2 weeks ago when I committed to this endeavor, and listen, I don't think the web layout is perfect. There's definitely some things that I would probably go back and tweak, but I'm actually really quite proud of having just gotten it all out on paper, so to speak. So I think that'll be good, and I think it'll be a good resource and reference going forward. I don't think I'll have to throw all of this out when I start again on the next version. Broke both my arms. Documentation always takes forever and never is thorough. Yeah, so one of the things, you're over here now, one of the things that I have done for tonight is I have a little pad of paper. Oh, no, I don't. I meant to get a little pad of paper. I'll use this. I have a piece of scratch paper now on the bench beside me here. And as I go through tonight, I get to take notes on the things that I forgot to document, because nothing illuminates the things you don't know quite as well as trying to explain them to somebody else. So tonight, as we go through trying to build the thing by the instructions for a change, we'll learn what I forgot, and I'll take notes on it, and we'll just go ahead and make the thing better. I don't think there's anything really else to say before we dive into talking about it, other than tonight my beer of choice. And again, if drinking is not your thing, that's no worries at all, but I am drinking a Two Brothers Wizard Staff. Here, there we go. A Wizard Staff IPA. It's a 5% pale ale. It's very juicy. As my wife said, it sort of disappears after you drink it, which is, it's really quite nice. I'm also going to try and remember to unmute myself after I mute myself for sip time, so we'll see how that goes. Feel free to yell at me if I forget to unmute. Everyone always does. And if in a real pinch, the phone number on the bottom of the screen rings this red telephone back here. So if I've really gone off the rails or I am talking into the void, you can always just call me and tell me that I'm doing a bad job. Chris says, is there a beer that doesn't disappear when you drink? I mean, I feel like an IPA, you get that bitter, and then you get that long bitter, aftertaste, I guess is the only word for it. And this one kind of says bitter fruit, and it's gone. From Two Brothers here in the Midwest, which is very tasty. But I take your point, Chris. I take your point. It's not like there's really beers that hang around so much. Or at least hopefully they're not. I want to say before I dive in, this was a super fun thing. I just threw this together in the past 20 minutes. It's 3 little mini moving lights from 3 different generations. So this one is an 0.9.4. Actually, this one might be an 0.9.4 control board as well, but it has a different PLA for the body. And then this is the light we built 2 weeks ago that has the NeoPixel star as its emitter, as opposed to one of these 10-watt LED stars. That's why it's blue down in there. I didn't bother writing up a RGB chase for it, although that would be really fun. But I just decided to focus on getting them all working. They're just stuck down to the desk with sticky tack at the moment. But it feels good to have a bunch of these. Just I set all their addresses. I wrote the the control software on another little control board there, and turned on the power, and they all just work. And that's a great feeling in the life of this project for sure. Yeah, we'll just dive in. I'm going to try and remember to, so I'm playing with this new, agenda scheme in the back, on the bottom of the screen here, where we can see, what part of the night we're in. I don't know, I've had a good time making it. We'll see if it's actually useful. But right now, we're in the introduction. Let's go on to talking about the background of this project, because I don't want to necessarily assume that everyone who is here with us this evening, and if you are here this evening, feel free to jump out and say hi, or just hang, no worries. Oh, no webcam over there. Where? Well, that's all right. You don't really need to see my face. There it is. Huh, it's in one view but not the other. How bizarre. Hi. Just a little bit of background on the Demilight project, which will give you a little bit of context for what we're building tonight. And some of you who've been here before, I mean, Chris, I know you've been here for a bunch of these evenings, will know this already, but just going back in time, this is on the main Demilight page at jeff.glass/Demilight. The project started with a really giant light that was just an STL file that I downloaded off of Thingiverse, and over the past really 18 months that I've been working on this, on and off as a hobby project, it's evolved from a board that had a little external control board. Maybe I can zoom in on that some. Let's see if I open that in a new tab. Yeah, so I first built a version that would just sort of like prove the concept of this form factor using an external controller, and you can see there's an Arduino Pro Mini and a little socket down there, to some DMX-based hardware just to like validate the idea of receiving DMX and how that would work. And then from there, it's been a process of like basically refining the physical design along with refining the PCBs. Starting in version 0.9.1, I was experimenting with surface mount assembly through JLC PCB for the first time, which was has some gotchas, and I have stumbled across a couple of them, including replacing all of my resistors with LEDs on one run, which made them not work really at all. And in version 0.9.3, had a routing error on my PCBs that caused the lights to literally catch fire when you turn them on. So 0.9.4, I think I've smoothed out all of the worst of the bugs and improved the form factor enough that I feel good about getting the files out into the world. And so they're out in the world. If you go to jeff.glass/Demilight and click on the build your own, all of the files are there now, and those will be what we're referring to tonight. Hey, Thomas, speaking of building tiny lights, good to see you here. Thomas is building his own somewhat larger, somewhat more precise light, for sure, than I am. Chris is here for the fire. Fingers crossed tonight that won't happen. The whole point is that this design doesn't catch fire. But I guess no promises. So yeah, we're just going to go through the parts and pieces that go into this, and then just go through the assembly sort of step by step, both for those who are here live, and then this video will just be on YouTube for people to reference after the fact. And then we'll sort of talk about the next steps for the Demilight project, because like I say, this is not the end of things. This is just the sort of first relatively stable version. And I also got some new cool toys in the mail just today that I'm really excited to talk about at the end of this, that are going to help with developing sort of the next steps of the Demilight project, and a sort of side product that I actually thinking of selling as a product. I have said before, I may at some point sell these control boards like on Etsy or Tindy or something, just because I think that's the sort of most convenient way of getting them out into the world. Because I would love for people to have them and make things with them. But this other thing that I'll tell you about at the end of the night, I think could actually be a product that like theater and tech and DMX professionals actually use. But that's a little teaser. We'll get to that at the end of the night. I'm going to power these guys off for now, just because they make a bit of noise, and I'm going to tilt my overhead camera to a different part of the workbench. There we go. Let's see if that'll stay. No, it won't. Well, a little bit of bonus tummy cam for those who are here early. Thank you very much. And as I get the camera situated on the build area. Broke me are BBMA, we'll call you. I definitely buy a couple of those boards. Yeah, right. It's like, it's not a terribly hard process to go about fabricating them through JLC PCB or PCBWay or something like that. But like for someone who just wants a couple, right, which I 2 or 5 or 10 to play with, like if you haven't gone through that process before, maybe it's not worth it. So yeah, it's like throw them up on Tindy for a nominal price, and just so people can like buy them and play with them. They don't have to worry about that step. I think it would be fun. Oh my goodness, Thomas's moving light, it took a whole spool of ABS. Oh, including 250 grams of wasted filament. Well, I mean, that's just part of the 3D printing game, right? Like that just comes with the territory. Ooh, Ender 3 has some, yeah. So I have never actually used the Ender products, but I hear decent things about them. What upgrades are you looking at, BBMA? Something sounds wrong about it. Broke both? Broke? What are you looking at for your Ender? As we dive into the assembly process here. I'm going to take a moment and get my face up here. We're going to be looking at this view a lot tonight. Figure out, I probably turned it off during some USB shenanigans. There we go. Bomb file is missing from the site. Oh, thank you, Chris. That is good to know. Let's see here. So down in the... Here, I have annotated bomb. It's just not not linking correctly. Page not found. Annotated bomb. Gotcha. I will fix that immediately following the stream. In fact, let me put it on. My first thing to fix on the website is actually put bomb on site. We'll look at that document a little bit tonight, but I think it would just take a little bit too long to like get into the file server and actually plonk it there. It's probably just that I've typed it bad. So yes, so this, we'll just go through the website. It's kind of the goal of the thing. So here we go. Let's talk about, here, I'll remember to update my little part of the night indicator at the bottom of the screen there. That'll be fun. So the Demilight build site starts with, a little bit of an overview, what we're doing here. This is the little data sheet that I showed off a couple weeks ago. I had a friend whose husband is a big old nerd for lights. I guess partner, maybe not husband. Asked to purchase one of these lights for me for Christmas. The purchase one of lights from me for this partner who is a giant lighting nerd, like works in the lighting field professionally at a very technical level. And I said, well, that seems fine. I can get that happen. But he's going to need some additional info as to like when he gets this thing in a box, how does it work? What is this DMX addresses? How do I power it? And so on. So I made up a little like 2-page data sheet with control data and disclaimers. So like, don't sue me if your thing does catch on fire because you built it yourself. So that might be fun to look at. I probably put that together because I think it's useful, and partly because I think it's fun. The 3D printed parts, so there are 3D printed parts for download. There are 6 parts that you'll need, and here they are all on the workbench. So they all have, the names I don't know that I'm married to, but the way I'm calling them is the case, which is this large square part that the PCB will mount in and will sort of serve as the base of the light itself. We have the lid, which will slide into this sort of slot on the case here. That's going to hold the upper assembly of the light. We have the servo cover. So once we've mounted a servo on here to pan the light, it gets covered with this, basically just an aesthetic cover. We have the yoke, right? So we have this little piece that's going to attach the body of the light, sort of the head of the light, to the case part. And then we have the 2 halves of the shell, left and right. The left half of the shell attaches to the yoke and actually will be the suspension of the light. And then we have the right half, which is just aesthetic. So that's just going to snap in there and just hide the guts, hide our crimes a little bit there. So those are the 6 3D printed parts. As far as printing goes, and we'll stay on the parts here for this. So the intention is for these to be relatively easy parts to print. You have 3 parts that are basically flat and boxes, right? So we have the case is a box, the lid is a box, and this is just a flat plate with some protrusions coming out the top there. This piece in particular, because it has these overhangs for the lid, so I recently accidentally printed this with supports. So I had supports basically running up the inside of the print there, just to catch that lid, and it actually worked quite well and reduced a lot of the tolerance issues I was having. So this part may be worth printing with supports. The others should not be necessary. Depending on your printer, you may want to print the body pieces with support because the overhang angle on the bottom here is fairly severe. So I should say all these parts are printed on my little Maker Select V3, which you can probably see just up. It's hiding up on the shelf behind me here, behind sort of the blue light there. It does fine with this overhang, but it's a little bit, you can probably tell it's a little bit crunchy. But it's okay. Some of these other parts, I actually don't know that I have any of these on the bench. For a while, I had access to the Prusa Mini in my workshop at work, and that had the overhang was no problem for that. It's just sort of barely on the edge of okay for my Maker Select. But so you will have to do some diagnosis of the parts for your own 3D printer, but they're meant to be fairly easy to print. And this image on the website is meant to show you the proposed printing orientation for the various parts. The yoke, it doesn't really matter, but that's how I print it. And similarly, print settings are going to be kind of up to your own discretion, knowing your printer, knowing your material. All of my prints are in PLA, just because it's really easy to print with and there's nothing terribly mechanically intensive about these parts. But PETG, ABS, whatever you are comfortable printing with, go for it. It should work in just about anything. Let's see. Broke Both My Arms says, I have a metal extruder, a PI bit, and a PCFE tube installed. Got an SKR mini board and a Raspberry Pi running Repetier with a RPi cam. Cool. Yeah, having a webcam on the 3D printer is a really neat add-on. I think that's a good value add. The PEI bed, so the thing I missed most about this Prusa Mini that I had access to at work is its really excellent, PEI flexible build plate. Maker select build plate, the adhesion is just so much worse and so much more fiddly. You take that and you lose, you subtract the auto bed leveling that the Mini has, and I'm really pining for the Mini at this point. But those are like excellent mods. Yeah, Thomas, hide our crimes. We like to hide our crimes a little bit. So, and like any 3D print, I should say, of course, there will be a little bit of post-processing that you'll have to do. Depending on your printer, there may be some filing, there may be some cleanup. I just did the very basic most post-processing on these. You can see there's still like a bit of brim hanging on there. Like I haven't cleaned it up terribly much. There's a couple of specific mechanical interfaces that we'll get to in a little bit where the tolerances are deliberately tight. Just because, and we'll see where those are. So it is expected that there are a couple of key places that you will have to file because the tolerances are deliberately too tight because I don't know your machine, I only know mine. So I'd rather make it too tight and then you can file back rather than making it too loose and then what do you do from there? Let's see, Thomas really likes PEI flexible beds. Yeah, for sure. To be honest, I have never printed in ABS on anything other than like a commercial printer, a public printer. I know Chris Wick, who's in the chat tonight, does a bunch of things in ABS that has strong positive feelings about it. So, which I just don't have any experience, but there you go. Let's see. Okay, so the PCBs, and this is probably the thing I'm guessing, and tell me if I'm wrong, that is probably going to be the biggest jumping point for folks who are going to be building these on their own. So let's talk a little bit about these boards, what they are, and how you might get them assembled, or some alternatives if that's not what you want to spend your time doing. So on the website here, we have just a download spot. I know the text is tiny there, maybe we can zoom in a little bit, but you can pull this up on your own if you want, jeff.glasses/Demilight. You can download the Gerbers, the drill file, and the assemblies, basically everything you would need to have these circuit boards manufactured from an assembly house. And here's if you're interested in them, here's a full list of the Gerbers, which are the file type that you submit to a PCB assembly house or a PCB fabrication house to have your printed circuit board made. You have the top and bottom column layers, your profile, which is sort of your outline, both sides of the silk screen, and so on. And then where you want your holes drilled, and then the assembly. So there is the bill of materials that is the full BOM for the entirety of the device. Then there is the BOM just for the pieces that would be placed if you were getting this assembled, right? So anything that's a through-hole part or something that's optional is not included there. And then you get a top-side placement file, which is the sort of XY coordinates where all of the components are placed by machine onto your board. Now, these are sort of raw outputs from Eagle, which is the program I do all of my PCB design in. Depending on where you're having these fabricated, you may need to do some reformatting or moving columns around or titling things in really specific ways to make them fit the requirements that your board house requires. I will leave that as an exercise to the reader. I do all of my assembly these days through JLC PCB's assembly service. And so in the annotated BOM, which Chris pointed out is not currently correctly uploaded, but will be shortly. If you're watching this not live, it's uploaded correctly. I've put the LCSC part numbers into the annotated BOM so that you can use them in the JLC PCB's assembly service. LCSC is the components arm of JLC PCB. But for those who want to use a different assembly service, something stateside or PCBWay or any of the lots of the other services that are out there, each component is notated by what it is, what size it is, its footprint, and a description of what it's doing. In fact, here, I'll just pull up that document now so we can have a look at it. Let's see if I can get that here. Annotated BOM. And like I say, that file is no longer available. It's not available to me? I made the thing. That doesn't seem right. Here, let's find it. I'll just find it in Excel. We'll see if the display will play nice with me. Annotated BOM. There we go. So when I have this thing fully uploaded correctly, let's see if we can zoom in any here. Let's see, just so we can see the columns a little bit better. Yeah, there we go. So for every row in the annotated BOM, you'll have the designators on the board, right? So that would be on your PCB, where's my blank? Oh, here we go. So on your PCB, each part will have a little designator by it. And certainly on the Gerbers, they will tell you which part is which. We've got quantity, so like C1 and C2 are we're over here now. Are 2 parts, right? So C1 and C2 are identical, so there's just a count of 2 of them. They're 10 microfarad capacitors. They're surface mount parts. They're 0603 parts. Here's the LCSC part number in case you wanted to get these assembled through JLC PCB or buy your parts through LCSC. A brief description of what the part is and sometimes its purpose, right? So these are 10 microfarad, 25 volt surface mount caps for power smoothing on one of the power rails. And then over in the notes here, I've said you need 25 volt capable capacitors for the positions on the V plus rail. Since this light can take up to 24 volts DC in, we need to use like a 25. Ideally, we'd use like a 30 or a 35 volt DC capacitor, but 25 volts will just barely cut it. People have some opinions about ABS. Let's see. Chris has just started doing PLA. PETG, so Chris has said this to me before, PETG is really, really tricky for his machine. On the Prusa Mini and actually on my Maker Select, it's been fine. So someday when we can get together, Chris, we should get all our machines in the same place and figure out how they're different. Let's see. Broke Both My Arms says, I haven't soldered SMD before. Would this board be a first good one to do? I have a TS80 but not hot air. So I don't know this would be a good first board. I think it would be an okay second board. I actually have a proposal for you for a first board, if I can remember where I put it. Maybe it's just here. I have a suggested product that, if you've never soldered SMD before, is the one I recommend you start with. And actually, there's a lot of different varieties of these. So, just move these guys for a second here. So this is a little kit. I mean, obviously, it comes in like a plastic bag, and I took it apart and put it in a box to put in storage. But it's a little SMD practice soldering kit. And you can get these all over Amazon and eBay for like really cheap. Like I think this one was like $9 with Prime shipping. And if you get them, non-Prime shipping or eBay for slow, they're like $3. And what it is a series of parts. You get, a 10, 1206 resistors, right? That's a fairly large SMD part. And then you get 12 or 14 0805. Then you get 0603 and then 0402, which is really tiny. And then a variety of LEDs, some ICs in the middle here, and some diodes. And when all is said and done, if you've done it right, it makes like a little flashing pattern around the little LEDs here, just as a little casual thing. You also get like a little neat reference card out of it at the end with inches and millimeters and various trace widths and various footprints and things. So this is a great way to get started with hand soldering SMD because you get to start with like fairly large stuff. Like I would say do all 10 or 12 of the biggest ones just to like practice and see how that goes. Then you get 20 of the 0805s to do next, right? And really sort of build up those skills, figure out your tweezers. Do you need magnification? Do you need extra flux? And sort of work your way smaller. All of the surface mount resistors and capacitors on the Demilight board are 0603, which is about as small as I can comfortably hand solder without magnification. Although magnification helps, but like that's as small as I ever really care to be working if I have the choice. So that's as small as you would go on here. The 0402s are really tiny for hand soldering. But when I was doing these all by hand back in version 0.9, you certainly can assemble these by hand. I just wouldn't do it first because like the layout is not as kind to you. Here, let's see if we can focus on this. Like doing something like this little resistor or this crystal, especially, which has leads buried under it, or this IC here, which is the LED dimmer with these J-wing leads, is not going to be as kind to start with as something like just a built-in practice board. So Broke Both, I would recommend starting with something like this as your first, or maybe second. Maybe get one of these and one of the ones that makes a little clock when you're done, and just build up some practice skills. Just think of this as a warm-up and then move on to something like this. Great question. Let's see. Chris asks, have you done a video taking a schematic and setting it up with JLPCB with the SMD parts? I have not. I should, though. The process of like how you would take these files, say, or take a design of your own and actually order a video, order an assembled circuit board. That would be a good one to do. I should say there is a YouTuber who did a really nice job of sort of going through the JLC PCB assembly process. And I think I linked to his video in the video that I did about using the Eagle, like the live stream about using Eagle as a PCB layout software. I think there's a link in that description. Maybe we'll go and dig it out later on, because he's a good resource. I'm just blanking on his name at the moment. SMG Electronics, I think it is. SMG, Sierra Madre Golf Electronics. Good place to start until I get around to doing it specifically for this. Yeah. So just a few other things. So, the bomb has all of the various parts in it, their various annotations, some notes about what they're used for. And that's this. If you were getting these assembled by a board house, you would basically have them stuff all of the surface mount parts. And then down here at the bottom, there are just a couple of through-hole parts that I am assuming you would probably assemble for yourself. And we'll go through those at the end. That's just the 5-volt regulator and the connector, the big old Phoenix pluggable connector at the end. So this will be up on the website soon, so you can have a look through it, both as an Excel file and as a PDF, whichever one is easier for you. For the stuff that is through-hole, because I'm assuming you might be ordering this from a board house and then, putting these parts in afterward, I've put a couple of different options in the bomb. I've hidden it a little bit there. Put a couple of different options for each of them in here. One of them being like, the actual nice, I'll make sure that works too. The actual nice part from DigiKey, say. I don't want to set Edge as my default browser. Oh no. And then like the cheaper version that I use when I can stand the long shipping, like the AliExpress version or the Amazon version or what have you. So just so there's a few options for people to play with. But we'll get into what those parts are when we come to assembling them. Don't save changes. That's fine. Let's go back to the website and see where we're at. So there are, in addition to the parts on the circuit board and the 3D printed parts, there's a few other parts you will need if you want to build one of these little guys. Oh, hello. We're very zoomed in. Yeah, super cool kit. It really, will build your confidence very quickly as you start doing a kit like that. So a good place to start with SMD. The other parts you will need if you are assembling a Demilight for yourself, you will need, maybe most importantly, the LED emitter. So the Demilight is designed, the circuit board at least, is designed around the idea that you have possibly a multi-LED in series setup where you have a relatively high forward voltage, as opposed to LEDs in parallel, which would have a low forward voltage but a high current. So the dimmer on the dimmer chip on board here is an AL8860, or optionally the AL8861. Same thing, different package and approved for automotive use, I think. But this is in this form factor is a 1 amp dimmer at up to 35 volts, 40 volts, I think. You start to run into other limits on this board before you got to 40 volts. But a lot of the higher power LED stars, not a lot of them, but some of them are like 3.3 volts forward voltage at, 3 amps, which would not be compatible with this board. What you would want is something like this, which is a, 10 or 11 volts forward voltage at up to an amp, which is compatible with the AL8860 dimmer on here. So you could use one of these. Now, I get these from ledsupply.com. This is all referenced on the website as well, but I think it's more interesting to just show you. LEDsupply.com does these nice. So these are 3 Cree LEDs in what they call a 3-up configuration. It's just 3 on a single circuit board, all broken out to little anode and cathode pads here. So you can get that to focus. Nice and easy to solder. You could also do something a little less intense and a little less bright. So this is a similar idea, but just a single LED. These also are a lot cheaper. So if you're not looking for a ton of brightness, these are a decent option. Again, up to an amp on the AL8860. These are pretty punchy, like 3. If the forward voltage of a white LED is like 3.5 volts, you get up to like 3 watts of white light out of these, which is pretty bright. If you've seen like a 3-watt LED flashlight, you know that 3 watts of LED is pretty punchy. So that's always an option. You will need, another part you would need is a heat sink, probably. If you're using an LED heat source that makes a significant amount of light, you probably will need a heat sink of some kind. These are the ones that I have been using, and the way that I figured out, to be honest, the size of heatsink that I needed was, sorry for the clatter, I bought one of these heatsink assortments on Amazon at one point and just sort of sized them around until I found one that fit in the body. The one that I'm using currently is the 22, no, is that true? No, the 19 by 19 by 5 millimeter heatsink. You can tell because it's mostly depleted. A 20 by 20 millimeter heatsink will fit inside the body. It's just really snug. So since I have a bunch of each of them, I sort of go back and forth. I would say if your LED star is going to be putting out more than a couple watts, you probably want to think about slapping a heatsink on the back of it. What we found in our burn-in testing like a month ago on this channel was that the first thing to fail as this started to heat up was not the LEDs or honestly the plastic body of the lights. It was the solder that we used to attach the wire to the LED star. Now we could like look at how much power you could put out with a high temp solder, say, but that seems like an advanced step for people who want to go there and really want to push their lights as bright as they can go. Yeah, Cookie's just dropping fire emojis in the chat. You probably want to keep a fire extinguisher. Hanley points out, Nate, it's good to see you. Bucket of water might be good. Not do this like near any open sources of flammable gas. Maybe somewhere that's a little, just like a little far from wherever your wife is spending the evening, where your husband or your partner, I should say, far from my wife, who gets concerned when I shout when I get burned. Or whoever may be concerned about you, pets or anything who doesn't like burning smells. So a heatsink, in any case, is a good idea. If your heatsink does not come, some come with like a peel and stick thermal adhesive on the back. A good alternative, I'm sorry for the tummy cam, is some of this stuff. This is thermal adhesive tape. It's a lot easier to work with than like thermal grease that you would use to stick a CPU together, although that is probably a better thermal conductivity. This stuff works pretty well, and it's almost exactly the size of our heatsink. So just cut a snip of this off and stick it on, stick the LED to the back, and you're good to go. So that's a useful tool to have around. Let's see what else we need. Oh, of course. So to move the light, the Demilight is centered around a couple of again, you'll get the sense as we go along, and you'd be right that like the point of this is to make these lights pretty cheap, like make them really, really accessible. Sorry, spitting on my camera there. That's good streaming right there. Make them cheap, make them, all accessible parts as much as we can, try and centralize anything fancy into the PCB. But then like the rest of the parts are 3D printed, they're easy to buy from Amazon or eBay, and they're cheap so you can make like a bunch of them, is kind of the theme here. So, 2 standard 9-gram hobby servos. I get these in quantity for about 80 cents a piece. If you buy them in slightly smaller quantities, maybe $1.50 each is a totally reasonable price to pay. This design does not make use of the servo horns, which are the plastic bits you would normally attach to the servos. So don't worry too much about, do I have the T, do I have the arm, do I have the whatever? We won't actually be using those. You will need, and every servo, they all come from like the same 3 factories, so they will all have this, but we will need 2 mounting screws and the attachment screw for each servo. So when you unbag them, which I guess I'm just going to do now, make sure you save those because they will all become critical. I actually have here, because I don't use these servo horns and I've been repping on this design for a while, I have a container that's just, a giant pile of these little plastic horns, and I feel like there's an art project in it somewhere. Or maybe like some earrings or something. Like it's, here, I'll show you. Got like a whole box of little servo horns that I'm not sure what to do with. Also like spare screws and stuff like that. Let's see. Thomas says I was doing exactly that. Oh yeah, Tanya, keep the fire extinguisher close. Is never a bad rule. Mine is right. You can't see it, but it's within arm's reach, just off camera that way, just in case. So got a couple of 9-gram servos, nothing fancy about them. In the instructions for assembly later, I put like how long the wires need to be. I've never had some wires that are too short. These are about 9 or 10 inches. I think there are some out there that have really, really short stubby wires, but get a standard 9-gram servo for cheapies and it will be just fine. You'll need some wire. So there's a couple different places on the light that you will need wire. Here, I'll unplug our sample guys so we can have a look at. So there's wire that is powering the LED inside of this head. That will need to be fairly flexible, right? So picking something with a nice stranded wire with a nice slippery jacket is a good thing. And then ultimately some wire to connect your light to something. Now I like to use, sorry, tummy cam, as always. Ooh. Tweaked my audio interface there. Hopefully everything is still sounding okay. I got myself because I'm building a bunch of these. I got myself a roll 100 feet, which is way overkill, of this 4-stranded wire that's meant for like wiring up RGB LEDs. There's a lot of good 4-wire products out there for wiring up RGB LEDs these days. Now I got the stuff in like a jacket because I think it looks nicer, but the unjacketed stuff is a lot cheaper. And you can get it. There is some stuff that is 22 gauge and some that is 18. I would get the 18 gauge wire because we're gonna be pushing, up to maybe half an amp through. And I'm sure the 22 gauge would be fine, but why chance it at that kind of current? So 2 different kinds of wire, one to hook this stuff up. And I should say, like, this design, part of the point of it is it's fairly robust against what you might, throw at it. So like, if you just want to wire these up for testing with bell wire or stranded wire from your workbench or stick it into a breadboard, it should be just fine. I just, if you're gonna like wire these together and stick them somewhere and do something fun, maybe some 4-conductor wire is more useful for you. What else we got here? Oh yeah, so a couple of optional pieces now that you can take or leave depending on what you want to do. In fact, I think I've covered these with sticky tack. So if you wanted to hang a bunch of these on a truss, on a little mini truss, and do something fun with them, the design is meant to take 2 3mm by 3mm, I guess M3 by 3mm heat set inserts. You can tell I did a really crummy job of installing that one. These just melt into the base of the light using a soldering iron. We'll talk about that in a little bit. But if you want to put hanging hardware on them, like this guy has, this is a piece of an older light. I should put these clamps up on the website too. Let me take a note of that. Clamps on website. 2 little M3 screws, 2 M3 inserts. You can hang this on a truss and do some fun things with it. Speaking of truss, I should have linked to this in the description, but I think it was Cookie who has done some really nice designs of truss work for miniature projects that come together with like M4 screws. Cookie, I should have linked that. I don't think you can put links in the chat, but I will make sure that happens because those are really cool bolt together truss systems for tiny lighting projects like this. And then the last item that you can take or leave depending on what you're doing is this wire guard. This is some 1/4-inch white sort of wire wrapping. It just keeps the presentation a little bit cleaner because you have the 2 wires for the LED star and the tilt servo wires coming down from the head to the base, and that just keeps things a little bit neater. You don't have to use it. In fact, this other light here that was running around earlier that we're doing NeoPixels with doesn't, right? So it doesn't look bad. I just like to put it there because it sort of tidies things up a little bit. So if you want some of that, I'll link to it on the website. The specific one I use, but any cable wrapping, any color would be fine. This is 1/4-inch, seems to be about right for this wiring, for what it's worth. Those of you who are here often know that my when I ask for questions, it's really just an excuse for me to pause and wet my whistle before we carry on. So, questions or comments at this point? And remember to unmute yourself. We're 1 for 1 now. That's very good. Yeah, that beer just like vanishes into the night in the back of your throat as you drink it. Very tasty. As I'll ask questions as we go along too. Part of this is to for people who are interested to ask about it and for me to learn what I've not made clear. So feel free to throw stuff out in the chat as we go along. But other than that, we'll just dive right into assembly. So let's go through things. This curved truss is taking a while to troubleshoot. Yeah, that I believe. I'm excited. I did a curved truss design myself at one point. I'll grab it for just to show off how bad it is. If I can find it here. Yeah, you get full tummy cam privileges tonight. Those of you who have been here before know I'm filming from the workbench, and all of my storage is sort of immediately behind the camera. So whenever I have to grab anything, I'll just get to see what fun sweater I'm wearing, as long as it's sweater weather. And maybe it'll be crop top season soon enough. Well, I can't find it, Cookie. I'm sorry, but yours will be better anyway. So I'm excited to see that when it comes along. Let's see. Ooh, Broke With Me Arms has good questions. Let's see. Have you thought about battery power and Wi-Fi? Ooh, would be cool to have a slightly larger base with a small battery and EST32 with ArtNet or OSC over Wi-Fi. Yes. So good questions all. 2 answers there, right? Batteries and Wi-Fi. So batteries, yes, I have thought about. That will probably be a thing, if I do pursue it, that I would do after pursuing this project, which I'm teasing again because that's the thing we'll talk about later, which is going to require either either a small LiPo or possibly 2 AAAs to power. I haven't decided. If it's going to be rechargeable, it'll be LiPo. We can decide if that's a challenge I want to tackle. But once I sort of use that project to learn about battery power, maybe we'll incorporate that back into the light. I love the idea of ArtNet or OSC or streaming ACN over Wi-Fi. Would be a super cool integrated thing. I have never really worked in depth with the ESP32, but that would be a super cool feature to add. Other things on my hit list include, like, you know, controlling it in some raw way over over a USB connection, right? So if it had a mini USB charging port, maybe you can also do some direct control of the light using that. Might be kind of fun. So I guess short answer is yes, I've thought about it. I don't know that my skills are there yet, but I have some stepping stones to hopefully get to things like that in the future. Because yeah, being able to like plonk one of these down, you know, somewhere with a, you know, plonk it down, turn it on, it's got, you know, battery power and Wi-Fi and it just works would be super, super cool. There are some really cool products like that out in the market already. I imagine this more for like, you know, being as small and power efficient as possible. And it's your little, you know, it's your mini light lab at home or at your school, or it lights your diorama or your stream or I don't know what. But yeah, all good questions. Yeah, Thomas, it is my portable light programmer project. Some parts came today. Well, I'm getting ahead of myself. Ooh, let's see. Broke Both says OSC over USB using SLIP is possible. Could also emulate the NTEC API. Yeah, for sure. Like they have done some decent work on like both on the open dongles and in their pro dongles, right, where you can sort of pass DMX configuration messages to your dongle and have them go out. Could certainly do. That will actually tie into another cool thing I've got here to share later, but. And now I'm just teasing again because I got fun toys today and I'm excited to talk about them later. But let's talk about building one of these things for now. How do you say? So like I say, I'm just gonna like roll through the steps as written, and we'll see what we learn. We'll build another one of these little lights together tonight. If you're following along on the website, you know, now or in the future, reading through the things, there are a few steps in particular, and we'll scroll down until we find one that have like some specific notes, like, hey, like there's a little radioactivity symbol by a few of these steps. And those are steps that I'm like, here's one. The attaching the pan servo, which we'll get to, you know, later in the process, but like, this is a strong area of improvement, said past me. There are definitely like some rough edges on this project, and this is certainly not the final version. So as you're building one of these, if you're building one of them, and you see a better way to do something or a way this could be improved, do it. This is not a finalized project. It's not pristine. So if you're like, hey, this would be a lot easier if you just did XYZ, I encourage you to just do it. And then I want to see pictures. I want to see what people do with it. So don't take as gospel every single thing you read in here. So the first thing we're going to do is, and I'll zoom this back out so we have a little more room to work with, is take one of our servos, which will become the tilt servo. So this will be the one that lives inside the head of the unit. And we're just going to remember to thread the wires for it through the hole in the left side of the body here. This might be the first moment that you discover that you have to do just a little bit of post-processing, right? If you need to do a little bit of filing to get it to fit. On my printer, it fits just barely, but yours may differ. Zoom you in a little bit there. So that's all it is, step one. Remember to put the wires through the hole in the thing. Now we're going to attach it to the body. And actually I realize I have a little bit of cleanup to do just here because I'm having adhesion issues, I suppose, with my printer. I print with a brim, which is pretty annoying. I'm gonna take the brim out of this this inner hole here before we get too much further. All right, there's that. Oh, Thomas asks, do we ever learn the cause of frozen Jeff last week? No, I think it's to do with one of my USB hubs being flaky, so I have a replacement for that coming, but so far this week it's been stable, so I don't know what's going on, to be perfectly honest. To attach this pan servo into the left side of the body here, we'll take just one of these big pan head screws here, and we will screw it down into the sort of started hole in this side of the body. Just until, and depending on your servo, so I have found, you know, sourcing servos from a variety of places, the holes that are sort of pre-started in my prints are, work with the brand of servos that I get. But by brand, I mean like very specific manufacturer. They're mostly generic and unbranded. Depending on where exactly you get your servos, your little mounting holes might be plus or minus a millimeter either way. If they don't quite line up perfectly, don't worry about it. That's not a critical dimension. Just, get your screw started and screw the thing in, especially if you're using PLA or PETG. You won't have any problem screwing one screw into some soft plastic. So we're just screwed in like that. And this mounts using only one of the mounting screws, but we'll want to save the other screw for later. It's going to get repurposed into another part of the design. Brokeboth asked me a really good question, which is, what license is this released under? So that's a good question. I've been thinking about it a lot today, and I'd be curious what people think. My thought is Creative Commons by attribution. And this is the thing, do I release it share alike? Do I release it non-commercial? Does it really matter? At least Creative Commons by attribution and probably share alike, I would say. That feels like a fair license to put this all out under, so that you're welcome to use it, you're welcome to make it your own. As long as you say that, like, hey, Jeff Glass made the original one of these, or based on a design by, if you make it yourself and you want to put it out into the world, then you have to publish your piece of it under the same license, open and permissive license, which I like a lot. Creative Commons for physicals and MIT BSD for code. Yeah. So interestingly, so the code will definitely be. My code might be Creative Commons 0. Like there's nothing particularly fancy about it. The library that I'm using for DMX is a fork of a library that's licensed under GNU, the GNU Lesser Public License version 3, I think, and therefore mine is going to be as well. And there's a link to this in the code as well. I'm calling it the JDMX library just because that's how I started out calling it. It's a fork of the Concepted DMX library, which is LGPL, so mine will be too. I know I wouldn't necessarily have to release my improvements on that code, or like my code as LGPL, just like the improvements to that library, but it's all kind of just improvements to that library. So that's where my head is at for now. You're asking, Brokeboth, you're asking me good questions. Like that was my shower thought this morning. It's like, what? How is this licensed? There are not licensing terms on the website currently, I will say, but I've been thinking about it. So now that we've mounted our tilt servo here, we're going to solder a couple of our wires to our LED star. I'm realizing I need to get a little bit of wire here off of my spool. And in the instructions, I think I tell you how long these wires should be. 9.5 inches each, and that was pretty generous. That will leave you with some slack inside the body at the end, but not too much slack. So we'll just measure out a couple of 9.5 inch pieces of wire here. Use my flush cutters to just snip this off, and we'll have a chance to go back and make these like just the perfect length later on. So I'm going to cut these pretty casually for the moment. Doesn't have to be super precise. We'll go 9.5 inches there and cut. Get my soldering iron heating up now. Make sure it's got a chisel tip on it. That'll make life a little bit easier. I often forget to I leave the like needlepoint SMD soldering tip on the iron, and then it gets hot, and then it's like, well, dang. Now I've either got to change it out hot or wait till it cools down, and then it's a huge pain. I'll grab a bit of solder here, maybe a little extra flux, because this is actually a star that I have soldered and desoldered a couple of times for various past projects, but that's all right. So just gonna flux that up a little bit extra for those purposes. And I'm gonna strip a little bit off the end of each of these wires here. Now it will become important when we get to final assembly that we know which of these wires is attached to the positive terminal of our LED star, which one is not. So I'm just gonna mark arbitrarily one of these wires with black on the jacket here, because I'm using the same color of wire for anode and cathode. If you had two different colors of wire, say red and black, this would be a great opportunity to use both of them. I have this giant spool of like nice flexible 22 gauge brown wire that I insist that I'm going to use up on this project someday. So I'm just going to mark mine. Oh, Chris reminds me, safety gear. Thank you, Chris. I'll get the safety glasses on. I've been redoing my wall of tools. You can kind of see behind me here. to put the tools that I use most very close at hand for this kind of work. And it's only possible, frankly, because like I used to do 70 different hobbies and now I'm only doing 15. No, that's not true. I was doing like 6 different hobbies and now I have a couple. And so now as my interests have narrowed, I can really start to say, okay, I need a wire stripper close to me. I don't need a T-square. That can be, you know, further away. So one of the things, one of the things that I put there first, Chris, was safety glasses. Just to try and be better about putting them on and actually wearing them. It'd be nice if they weren't quite so dirty. First retrieval, exactly, Chris. Yeah, like having the tools that I use most easily, or the tools that I, you know, would like to be using the most, like safety glasses. I am not turning on ventilation as usual here because the noise on stream is just intolerable. I would usually you know, have my vent fan going, but for a couple of solder joints, I think my lungs will probably forgive me. So what I'm going to do is I'm just going to tin the ends of this wire just a little bit, and with some extra flux on the board, I'm going to just solder these wires in place. I'm going to do it, if you have an LED star like mine that has these little divots cut out of it, it's useful to orient your wires toward those divots, just so that they will sort of bend around the back of the star nicely later. Here's a nice little... I have my iron turned way up high, I should say, which makes soldering to these big, beefy LED star heat sinks a lot easier. Thomas says, licensing bends my brains a little bit. For models of airplanes want to use CC non-commercial. Yeah, it can be a complicated thing to think through, for sure. Part of what leads me to, like, you know, the Creative Commons licenses especially for the physical stuff is, I mean, at this point, like, I'm just a guy just sharing this with the world. Like, does it really matter? Like, no big company's gonna come along and steal this idea, and, you know, I'm not missing out on anything. But the other thing is, like, when I think about the process of developing this, there were so many. That was a poor job talking and soldering at the same time. So many resources in the world, and especially on the internet, that were incredibly useful to me and that I only had access to because they were, you know, licensed permissively or open source. I mean, even in this next project, as I'm thinking about, like, how am I going to add, like, a LiPo recharging circuit to this next project, which is not something I've ever really done before. But, you know, who has? SparkFun. And SparkFun publishes all of their schematics and bills of materials under a Creative Commons license. And I'm very grateful for that as a maker, and so I sort of consider it, like, for my little slice of the universe, like, I like to give back by trying to publish that stuff. I do also, I should say, I intend to publish, if not necessarily the original schematic and board file, I'll just publish it all. The schematic files, the board files, they're very messy, especially the schematic. We've looked at it on stream a couple of times. It's unreadable. But when it's cleaned up and useful, I will get it out there. I'm trying to figure out if I have a solder bridge on here. I don't think so, but now I have my multimeter also within arm's reach now, which it wasn't always. So let's just meter this out and see if I've done a bad soldering job here. Incidentally, I should say, maybe a good time to mention the AL8860 or AL8861. One nice feature of those LED dimmer ICs is they have short circuit detection. So if you do have a situation where you accidentally short out your LED star, you won't damage anything, you just won't have any light coming out. Let's see, I should have let's set this to activity, and looks like we're in the clear. Yeah, I think we're okay. Well, that's great. So we'll call that we'll call that a good soldering job. It's not, but it's good enough to be getting on with. Our next step is, we'll attach our heat sink. So I'm going to take our little 19 by 19 millimeter by 5 millimeter heat sink here. Like I said, there's lots of different sizes of these that'll work pretty well. I'm going to cut about 1 inch off of my heat sink tape. There's also, like, I bought a bunch of this because I plan to make a bunch of these. If you were just making a couple, can I pull one of these out quickly? Maybe I can. There is another product that is meant for heat sinks for the computer market that might be better for just making a couple of these, which is, I pull out, it's actually in my box of 3D printer accessories. Oh gosh. mess in here. These little guys. So this is a little thermal adhesive pad that you might use to stick down possibly a CPU, possibly just some other, hot internal part that needed some heat sinking. These come in like a pack of 5 for a couple bucks. So like if you're only building a couple lights and you don't want to spend the $8 on a roll of this thermal tape, maybe buying a little pack of those thermal pads is the way to go. They're really sticky, so be warned. Once you stuck them on and left them for a couple minutes, they are there for good. I am going to peel the backing off of this thermal tape, though. That's my solution of choice. Also, not the easiest thing. Thomas, thank you. Yes, yeah, nothing. It's not going to necessarily be good. It's not going to be the best, but it's a tiny moving light made out of like 3D printed plastic and 80-cent servos. Like nothing on this deliberately is the highest of qualities. I'm just gonna sort of center this up, stick it on there. All right, stuck. That's good. Next, what do we do next? Yes, we thread the LED wires through the body. Through that same hole in the left side of the body there that we shoved the servo wires through, we're now going to shove the LED wires through. You'd think this is like a silly thing to point out, but like order of operations on assembly here actually turns out to be fairly critical. I think the first time that I did one of these like assemble the light on stream things, I had to undo a bunch of steps a bunch of times. Chris, I think you were here for that, possibly. Just because, like, I had not made myself an instruction sheet. I ended up like, okay, well, now I'll attach the head to the yoke. Oh, now I can't attach the yoke to the body because the head's in the way, so I had to take that off. So, hence, spelling out every step of these instructions as best as I can so that we can follow them. So, those wires are just going to sort of thread through there for now and hang out until they're needed. If you're going to install this wire sleeving, this is the point to do it. Let's do it, because that'll be fun. Similarly to the wire, I have a note in the instructions to use a 7¼ to 7½ inch piece of this wire jacketing. So there's my roll of it. This stuff was like $6 on Amazon. We'll just snip that off. Let's see. Thomas says didn't make it in that day. Yeah, it was so like it was the comedy of errors of like, okay, well, I'll attach the head to the yoke. Oh, well, now I can't attach the yoke to the body. Well, so okay, so I'll take that off and I'll attach the yoke to the body. Oh, but with the yoke attached to the body, now I can't put the PCB in because the yoke's in the way. So I'll take the yoke off again, which is very silly. So it was the next day that I made a Google Docs version of the instruction sheet, and that became the basis for making the actual instructions that are now online. Because it was bad, and the order of operations, because things get in the way of each other, was fairly critical. So this stuff is super nifty. It does fray pretty badly. So there are a couple of strategies you can use to help it not fray into oblivion. And by fray into oblivion, here, I'll use a little scrap piece here. Maybe I have a little... I dropped my piece that I was fiddling with earlier. Right, so what we're going to do is sort of compress it so it opens up in diameter, and then thread pieces through it and then close it back up. But once you start to like expand this in diameter very quickly, you get these stray threads at the end coming all apart. So partly this 7¼ or 7½ inches is generous, assuming you'll have some fray that you have to trim off. So that's a fine length. There's a few ways you can manage that. For the sake of time tonight, I probably will just use a lighter and lightly singe the ends. You can also use a piece of heat shrink. Looks really quite classy. I don't know that I have handy the one that I did that for. Maybe I do. If I were to make these as show pieces, that is probably the way I would go. Nah, I can't find it. But especially doing like heat shrink that color coordinates with the color of like the light or the wrap. We get fire. Oh, yes, you get a little. It's not even a full size like barbecue lighter. It's like the bonus lighter that came with my barbecue lighter. But yes, that's just for you. Just a little bit of fire in your day. God, I saw the fire emojis out of the corner of my eye in the chat, and I had a moment of panic. I was like, what? It's all good. Fire is under control. So I'm gonna do the servo wire first. I'm gonna compress this sleeve a little bit and just get the head of the servo wire in there. And then I'm going to kind of inchworm it into the into the sleeve, but I'm gonna hold this servo wire in my right hand. I'm gonna use my left hand to compress the sleeve, grab the header, and then release my right hand. And we'll see that the servo header has moved sort of down the length of the tubing. And sort of by inchworming our way along, we can get this header through without it constantly getting stuck on the sleeving. If that didn't make a lot of sense, when the first time you hold this in your hands and work it through, it absolutely will. And before we know it, we'll have this sort of out the other side. So we'll just compress one last time. We'll get this to sort of slide through and out. There we go. If there's a real fire, we'll call the red phone. Oh yeah, I think I don't remember if I mentioned the phone at the beginning of this. Time is a construct, but yeah, if I mute myself, if things do catch fire and I haven't noticed, call 8150 Malort, which is the big emergency phone, and I will pick it up and see. The first time it rang during a stream, it was just my friend Kenneth, who some of you know, just calling to say hi, not knowing there was a stream going on, which was very nice. Let's see. Now, what I should have done is, because I stripped these to meter them out, they're becoming a little bit caught, so I'm just going to trim those back inside their nice slippery insulation there. There we go. That makes it a lot easier to feed those ends down through that meshery until they come out the sleeving. And now we have our two ends poking out there, one of which is marked because it's the positive attachment side and the other is not. And now we see all this fraying that we have here. So what I'm going to do is just take a pair of scissors or a pair of flush cutters and just sort of lightly trim off the worst offenders here. I think maybe the scissors will work better for this application. We'll trim just so we have like a relatively clean edge. Doesn't have to be perfect. This end is actually pretty good. And then we'll take our lighter and we'll just, there we go, just lightly singe the ends. You'll see they sort of melt. And what you really want is them to melt into their neighbors so that they stop each other from unraveling. So you don't have to melt very far, just until each thread is sort of touching, one or two of its neighboring threads, so it's not going to fray any further. And we'll do the same with the other one. So this leaves a little bit of a kludgy looking edge, or you sort of get this like knobbly thing going on. It's the fastest way I've found, so I'm doing it tonight for the sake of time, but the nicest looking way is heat shrink for sure. Right, so now we just get a little bit of cruft there. Ooh, a little bit of hot, a little bit of melt. But it's not going to actually sort of fray back any further. And we'll leave it like that for now. So that's the end of the sort of head assembly portion for now until we get to final assembly. I think I'm also done with soldering. Is that true? I guess until the PCB. So I'm going to turn the soldering iron off. I'm going to take the glasses off because they're fogging up here. And I'm going to ask for questions, which you know what that means. I just need some hydration. And by hydration, I mean the Wizard's Tower beer from Two Brothers. All right, questions if you got them, as always, throw them out. I'm going to throw a couple of tools back in the holder. This is the other nice thing about having the tool holder just here. I'll pan you over. Oh, that's going to be awful. It's just here on the wall next to me. Having everything literally just within arm's reach means like if it's not a pain anymore to put tools away. It's just all right there. There's a bunch more room to like continue filling in these parts as I figure out more and more like what I'm doing with this wall. Let's see, we were going to work on the base unit, yes. So, let's look at a little bit of print cleanup that we have to do here. Let's zoom us back out again now that things are a little bit bigger. So one of the places where tolerances are deliberately tight is the interface between the base and the lid piece, which are these two pieces just here. This is just a slide friction fit into the base. And you'll see right now it doesn't actually fit at all. So I'm gonna take my file and just file down. Partly I know on these prints, because I've done a bunch of these on my printer, if I file the sort of elephant's foot off of the base of my lid print here, then it will usually fit into my base print pretty well. So I'm gonna start with that. It's another filing stream, guys. It's been a few weeks. Haven't you missed it? But so like this is something that this basically, accounts for all the tolerance on my Maker Select. On the Prusa Mini, because it has a little bit more fidelity, I think, in the vertical axis, I have to do a little bit of filing inside the notches on the base as well. So like this will just be a thing, like depending on your printer, the 3D printing files are set up so that you will almost certainly have to do some filing just so you have a nice tight fit at the end of things. But where exactly that's going to be is going to depend on your printer. Yeah, so now I've got a nice sort of tight snap fit there between those two parts. So we'll take care of that before we move on to the next step. Oops, it's awfully tight. There we go. The next step is going to be these threaded inserts. And again, this is an optional step if you want to do hanging hardware, or if you're thinking about hanging hardware at some point using this method. This, I should say, and I think is notated in the build plans, this is an area that I intend to change at some point. We'll see when it becomes a priority. The threaded inserts, I think, are not a great way for locating parts that have to have a sort of a precise relationship to each other, just because there's a fair amount of play in the action of actually melting the inserts into your piece. This is also like, you know, just another bit of hardware that you would have to make this work. So I've got a half-baked idea about like a twist in and lock or something that doesn't require any additional hardware beyond the 3D printed parts. But like I say, kind of half-baked. So if anyone else wants to take a swing at like a better way to do this than the threaded inserts and screws, be my guest. That would be awesome. This just feels, it's just not quite the thing. But for now, for version 0.9.4, if this is what you're gonna roll with, or make a few of and then change later, which is totally cool, here's how you might do that. Yeah, so I certainly could mess around with the elephant's foot compensation. What I find is that putting the brim back on my prints there, Cookie, which it turns out I need for print bed adhesion because the adhesion is so poor, kind of throws off the elephant's foot compensation. Like in theory, those two things should coexist, I think, right? But for some reason, it's not really playing nice. I mean, maybe what I'm filing off is the remainder of the brim, I guess. I don't know. It looks like elephant's foot to me, but it could be just brim remainder. So fair point. WLL of those parts? Oh, we're working load limit, asked Chris. Not much. I think I put in the data sheet that you shouldn't like suspend these over anybody's head. If I didn't, I'll say it here. Don't suspend these over anybody's head. Just don't. Or if you do, I'm not liable for it. So my usual method for getting these to go in is I'll take a pair of tweezers to hold the part. I will come in with my iron off the part, get it just a little bit hot, and then plunge down in, plunge, and then when we have about 1 millimeter left, I'll pause, and we turn it over on a flat surface and rub, while the thing is still a little bit molten, and that means that the insert ends up nice and flush to that surface. Yeah, doing brimless. I mean, on the Prusa Mini, when I had access to it, I was doing brimless, and that was really nice. The Maker Select is just getting old, or it's just the adhesion is just not there. So once again, I'll do this for the other one. I'll heat up the insert for a couple seconds. I'll push it down using my soldering iron into the hole. Push. I leave the tweezers there because oftentimes once you sort of push down into the part, the insert can get stuck on the soldering iron, and that's something you don't want. Yeah, I did a pretty crappy job on this one too, so maybe you'll do better than me, or maybe you should practice on some parts that are not as critical first before you do this. Let's see. Thomas says, ideally you do threaded inserts from the inside. Yeah, this is not an ideal methodology, I imagine. Manage to make pockets that perfectly fit the inserts on the opposite side I'm screwing from makes it impossible to throw it. Ooh, Thomas, I'd love to see that workup. This is sort of the method I have always used, like coming in from the outside, but clearly it's not working very well for me. So yeah, send those my way somehow. That would be a cool thing to look at. Let's see, we've done our threaded inserts. Yes. So now we'll set that part aside for a second and we'll mount our other servo. So I'll take the second 9-gram hobby servo that we prepared earlier, and by prepared I mean took out of bag, and we'll slide it into our lid piece here, and you'll see there is only one orientation that it can go in because the wires come out the side of the servo here. Right, if you try to install it backward, the wires don't fit, so we come in here. You'll see also, so this is, like I said, these 9-gram hobby servos are all in theory the same, but they vary slightly. This particular dozen that I got, you can see there's a little bit of space between the mounting tab and these sort of ridges here. That's fine, because there's hardly any mechanical load on anything in this design, but you do want to be a little bit careful when you're tightening your screws that you don't over tighten them and like rip the posts off of your lid piece here. I have definitely done that before. So just be aware of what you're doing when you're screwing, I guess. So I'm gonna put the first screw in here. Ooh, yeah, you could put real hardware nuts into your print there and pause them that way. I have this idea. I have a gift I'm preparing for a friend, using some like speckled stone PLA that I'm excited to play with, which I don't think that my Maker Select is gonna handle, so I'm waiting for the Prusa Mini to come around. But sorry, you can't see anything about my hands, but here, you can look at my face. My hands are not going to be in the way of everything that's happening here. Where it's without spoiling anything, in case somebody I know ends up coming through, and well, I know you fine folks, but in case somebody who's involved in this endeavor it ends up watching this at some point, I want this thing to be a stone piece that has a certain amount of weight to it, and of course the PLA won't. So I've modeled up a 2-part print. It's a single part print with a big hole, a big void in the middle that I would similarly like pause halfway through and insert like either like lead weights like you'd use for like Pinewood Derby, or maybe just like a couple of big ol' like bolts epoxied in, and then restart the print so it sort of print around them and add a considerable amount of weight to what is otherwise a plastic part, and then do some post-processing on it so it looked really, really nice. There's a stone that's important to this friend in a thing that we do. But I feel like I'm being unnecessarily cryptic about a lot of things tonight, and it's very strange for what is ultimately meant to be an explanatory exercise. Wow, this is going great. I wonder if this is another case where I can see my, I should have lined this up a little bit more carefully. I'm not going into the sort of pre-started hole in the 3D print. I'm right next to it now, I realize. And so I'm having to sort of start that hole myself. I don't want to push too hard because there's not a ton of mechanical strength in any of these PLA parts, but there we go. Now I've got it started. We'll just get that in there. We'll try not to rip anything apart. Okay, so there we go. So now I've got my pan servo mounted into the lid piece here. And now we'll set that aside for a second and work on the PCB. I put this is maybe a silly thing, but step 1 of working with the PCB module is just inspect, right? If this is your first time ordering a PCB, whether you're getting it assembled or not, here are some things that I look for when I take them out of the package, just in terms of like assembly quality. Are all the tracks connected? Is the copper a good quality? Are there missing vias or missing traces, or did traces like become cut and fold over and then solder masked over? And is the finish correct and all that? So have a look at your boards. Make sure that they are of the right quality. Thomas says, make sure you didn't swap all your resistors with LEDs. I put a little note like all the surface mounts parts installed as specified. I guess in that case they were installed as specified. The specifier just did a bad job. So just have a quick look over, make sure your LEDs, there's no obvious flaws in them. You'll thank yourselves later. And then there are 4 through-hole parts to install, which we will go through now. So this is the order that I recommend installing them in. Of course, it doesn't really matter what order you put the parts in, but this is a good way that sort of prevents the parts from getting in each other's way. First will be the ISP programming header. Yeah, Thomas, this is just a 2-layer PCB. Nothing fancy here. 2-layer PCB, single-sided assembly. So nothing fancy at all. So the ISP header for the ATmega 32.8 microprocessor that's on here, and if that sounds like an Arduino, that's because it is an Arduino, needs a 6-pin ISP programming header for us to program code onto it when it does not have a bootloader loaded onto it. So we will install that first. I should say, as I'm prepping the 6 header pins here, this is another area of improvement. It's actually making a change in version 0.9.5. I have... we did a little circuit. We're actually on stream a few weeks back to look at could we integrate a circuit such that this could be programmed not with an ISP programmer, but with one of these much more common FTDI, quote-unquote FTDI dongles, these USB to serial dongles. Because right now we're going to have to use an ISP programmer, which, while not cheap, are not super common, whereas these things, because you use them to program Arduino Pro Minis and you know, other Pro-like devices, are everywhere and super cheap. So that, I think, would be a more accessible programming methodology. So version 0.9.5 will have that. For now, we're going to use the ISP header to both burn a bootloader onto it and to load the code. So if you have a 2x3, oh, I need my tape. Here we go. If you have a 2x3 header piece, it's all, you know, standard 0.1 inch header. You can use it here. I maintain a stock of just, like, you know, single row snap apart header. I don't have 2x3 pieces, so I'm just going to use 2 pieces next to each other and treat them like one 2x3 piece. And to make sure that they stay in the proper orientation to plug into an ISP connection, I'm just going to plug a programming cable into them while I solder. Just that just ensures that they stay in the right orientation, because they could, you know, splay apart from each other or various things. So I'm just going to plug that into my 6 pins here. And you see I've secured it with a little piece of painter's tape just to help them stay in place. I'm going to flip this over, and with everything still plugged in, I'm just going to solder a single pad here, right? Oh, let's get some eye protection. There we go. And now that that's started, I can sort of peel the tape back and just have a look. Is this nice and flush on all the sides? And it's a little bit cattywampus, so I'm going to maintain a little bit of pressure on this cable and just tap this solder joint and just sort of wiggle it into place with that solder joint's melted, so it's nice and flush with the board, right? And now that everything's sort of nice and flush and aligned, I can go through and solder the other 5 joints, and we'll have our ISP connector soldered in place. There we go, 4, 5, and 6. All right, so that's our first through-hole part. In this case, for me, it was 2 parts, but that's going to be our 6-pin programming header there. Next, we'll do the other 2 header pieces, which are the connections for those pan and tilt servos we were using. So we will need 2 more pieces of 0.1 inch through-hole header, 1x3. And it's just the same way we're going to insert these into the pan and tilt positions on the PCB. There's a little plus on the silk screen on the inside of the board there, meaning to indicate that, like, the ground connection of the servo will go on the outside and the, I guess its signal will go on the inside here. Let's see. Oh yeah, Thomas, you have a picture you either sent me or tweeted the other day. You have a PCB mill. Yeah, so no solder mask. It makes things a lot harder. I am loving the ease of having a commercially fabbed PCB. It does mean I have to wait like 8 or 9 days between revisions, but man, there are some real creature comforts to that. All right, I'm just gonna double check again that my alignment looks good. Retouch this one just briefly. Yeah, it looks good, and then I can go through and solder the remainder of my solder joints here. I should also say, you know, I don't know if I mentioned it earlier as I finished soldering this, but one of the things that, like, I think is fun about a project like this is, you know, this is the form in which I'm assembling all these parts, but there's no reason that anyone has to assemble these in just the same way. You know, maybe like a whole assembling a circuit board like this and the LED dimming is not so interesting to you, but you could just take the, you know, the lid, the yoke, and the head and, you know, plug them in together, and now you have a basic pan and tilt system. You could stick an LED, a NeoPixel star in there, whatever you wanted to, and then just connect the servos to, like, an Arduino Uno, or to a PIC, or to an STM32, and just use them that way. Or stick like a laser pointer on the head and have a little laser pointer that moves around or something like that. So I'm going through the thing that I make using these ideas and these parts, but, like, if there's any part of this you're like, I don't feel interested in that part, but this part is cool, just take that part and do something interesting with it. Because that's what all this stuff is for. Is just for, like, take my idea and riff on it, or make exactly this. Also cool. The penultimate through-hole part number 3, is our connector. We're going to use these Phoenix terminal style. And they're these pluggable terminal blocks. Hey, Dave, any part will do, actually. So we'll solder this piece into our PCB, and then this just becomes like a pluggable, removable header here with these screw terminals on it. So I'm just going to insert that there, turn this upside down, and just like the last ones, I'm just going to solder a single pad and then check alignment and then solder the rest of them. I encourage you to start with one of the two middle pads because the outer ones are ground in your VCC line and they have a lot of copper attached to them. Yeah, so you can see there, you can see how much that's floating now, but that's going to be really easy to adjust. I'm just going to take my soldering iron, just reflow that pad, get it nice and flush, and let the solder cool. And now that part's in alignment, right? So by doing just the one pad first, we give ourselves time to fix things like that. Yeah, laser pointer would be fun for a cat. Our dog loves laser pointers. Hook it up to an RF receiver and drive it like an RC car. You totally could, because most like at least in model airplaning, which is the only thing I really have any experience with. It's all servo style signals anyway, so you certainly could drive them like that. I actually had an idea about like repurposing one of these to become landing or indication lights for an RC plane. Because essentially, you know, built right into the board here, we have a little 1 amp LED dimmer that can handle high voltages. So if you had a 3S or a 4S LiPo battery on your RC whatever, you could reprogram the processor to interpret a servo signal in and just dim some bright LEDs out to hook them up to your RC car or plane or something. But I don't need another dimension to this project, but that was just a thought that popped into my head. Last of all, we're going to install the 5-volt regulator. So this is going to take whatever your incoming voltage is here and step it down to 5 volts to drive the microprocessor and the RS-232 transceiver and the other 5-volt parts on board, the servos, I guess. Nowadays, and these are both linked in the interactive BOM, which will be uploaded, I use these little tiny cheapy 5-volt buck regulator modules. When I started... Well, I guess when I first started, I was using a proper 7805, but because this is a linear regulator, it wastes a lot of power as heat. So you're really limited in like how much power you can pull on the 5-volt side because you're burning off excess voltage. Then I went to these. There's a few models of these encapsulated 5-volt buck regulators, which are, you know, this goofy form factor because they're meant to take the place of a 7805 regulator. I'm gonna use these for a while, and then I did the same thing, but I went to the cheaper AliExpress version, which are like 60 cents a piece in quantity 50. So those are pretty good. How noisy are the buck? They're not great, I don't think. With a little bit of bypassing, they're okay. They are far from the level where they would be problematic for our microcontroller, at least as far as what I can see. I wouldn't put them on anything. I don't think I would feel great about putting them on a project that had anything going on with RF in them, right? So like if I had an ESP32 project or an NRF, what are the Nordic products? The NRF 58 series or whatever it is. I would just be worried there'd be so much hash they wouldn't do anything good. But for an AT Mega, it's fine. Someday when I have my oscilloscope cam hooked up, we can have a look at that. I did actually give myself another USB webcam for Christmas, just a little cheapy one from Menards of all places, the hardware store, so that I could potentially have a webcam pointed at the oscilloscope, so it would be easier to flash back and forth to it. But I have not set that up yet. So now, especially for this piece, for the buck regulator, I'm just going to take my flush cutters and trim those leads off the bottom because there just isn't clearance for them in the rest of the board. All right, so that I think is all of the prep that we do for our PCB for now. So that's all the through-hole soldering. So this PCB is complete and ready to rock. Now we have a couple of steps to do to prepare it to be a control board for our light. The first of which is going to be burning the bootloader onto it. So this thing will literally have the Arduino bootloader on it. It's not strictly necessary, but honestly, it's the most convenient way that I know to easily to have someone program their own board in the field and get the fuses set up right to run at 16 megahertz with an external clock crystal and so on and so forth. So there are a number of ways, of course, to program a bootloader onto an ATmega 32.8. I put a link in the instructions that are online to a Adafruit's resource page for the various resources you can use to do that. I use one of Adafruit's little tiny USB tiny ISP programmers. It's about 18 bucks. Works really well. There is, in theory, you can use something like an Arduino Uno as a ISP programmer using the Arduino as ISP sketch. I found that to be a little bit buggy. And not super consistent. So if you were just going to make a couple of these, you could probably get it to behave well enough to work. Maybe. I really like having one of these external ISP programmers for this purpose. But this is another reason why the next version, 0.9.5, will have serial programming on it, because especially if I was going to, there we are, going to sell these someday, I would basically have a different header on the bottom, a sort of a surface mount header, that I would go in, burn the bootloader, and then sell them to on eBay, Etsy, or Tinder or something. So they already have the bootloader loaded, and then you just come in with your little FTDI dongle and program it just like an Arduino. And these behave a lot better than like the ISP sketch, and they're much more common than these. This, I think, it's $8 locally at Micro Center. I think I got this for $4 on sale, and they're really useful having these little Pro Minis around, right, which are like $2. A great disposable Arduino, as it were. So for me, the process is plug in the ISP header, and if you're using a standard ISP header, you'll notice the board has on the silk screen an indicator of which way the notch goes, which way the little pokey tab goes there. So I'm going to line up the tab on my cable with the tab on the board, plug that in, and we'll come over to my Arduino IDE, and I'm going to try to hit burn bootloader, but it probably will throw up yes. Sir. This is the one thing about these USB Tiny ISP is, for some reason on Windows 10, if it sits for more than like 30 seconds without being talked to, it like disconnects, and I don't know why. On Windows 7, I did not have this problem, and I don't know if it's just because this programmer itself is like 10 years old, or if they all do that. But if it happens to you, just unplug the USB from your programmer and plug it back in. So now I have burned the bootloader to and set the fuses in our chip in our microprocessor here. Now. Oh, I haven't updated the menu. Wow, I totally forgot about that menu. Where are we now? Pan servo, programming. There we are, Chris. Yeah, I knew I was going to forget at some point. Now that we've burned the bootloader and set our fuses on the ATmega, now let's actually upload the program code. And there's a link on the website to the current version of the Demilight code, which is it's very simple. I'm actually, this one's using the Conceptinetics library, but you should probably use JDMX just for forward compatibility. Just the current version of the sketch. So I'm just going to, again, unplug and plug back in my programmer. And then, hang on, did I burn the bootloader or did I just upload? I think I just did muscle memory and just uploaded. Let me burn this again. Yeah, I think I did this bad. Writing, reading, done, and we'll upload our program code. Thomas says, yeah, Thomas, so I got the Fusion not crashing luck. You got the Arduino as ISP luck. That seems fair. I think that's a decent trade-off in these things. So we'll finish uploading our code, and there we go. And so one other reason that I want this to be a little bit more easy to program is right now you have to set your start address at the time of code upload, right? So like this board is going to be address 4, which is actually going to conflict with, that'll be fine, because that's going to take the place of one of these other lights that we had in our demo from the top of the night. This is currently address 4, so we'll have them doing the same thing when we could do our demo later in the evening. There's me. There we go. So that would be a lot less onerous, right, if you could just program it with a serial programmer or with RDM or something else. So progress to be made there. But when you upload your code, just know that you are setting the address at that time. Yeah? Cool. One thing you want to do at this phase is, I remembered to update the bottom of the screen, thanks Chris, is center your servos. So, let's see, how did I instruct you to do this on the website? Well, the website says to do a smoke test first, which is apply some DC power and see what happens. And hopefully, using light touches to look for heat and deep sniffs to smell for burning, examine whether anything's gone horribly awry. Probably this is something you should be doing throughout the process, but if you haven't at this point, it's a good time to. So let's take our programmer off of here. We'll plug in, I already have a couple bits of wire in the other half of my Phoenix terminals, and I'll bring over the leads from my power supply. Go hook up our negative terminal, positive terminal. I should say, so these boards as designed do have reverse polarity protection. So if you get that polarity backward, it's not a big deal. It just nothing will happen. But when you turn the power on, we should get just a little red power LED. I have almost no current being drawn on the power supply, which is good. And touching lightly, nothing is getting immediately hot, including the regulator. So that's a good sign so far. Everything's going to plan. Turn the power supply off. Let's unplug that for now. Get it out of the way. Actually, we'll use it again in a second here. So before we move on with assembly, we're going to center both of our servos. And if you're using the Demilight firmware, software, whatever you want to call it, that I provide, the lights will turn on, and for 2 seconds, they will point to their middle position. So if you have everything sort of aligned, straight up, 0 degrees of pan, not left, not right, everything will be centered for 2 seconds, and then it will start responding to DMX. Just as like it sort of homes, so you can see what it's doing, and then we'll start responding. One thing that's nice about that is that it also allows you to center your servos for assembly, just using the board itself. So again, a reminder that the servos go with their ground wire toward the outside and their signal wire toward the inside. That's intended to be the meaning of the little plus symbol inside the servo. I'll zoom you in here. You can see the servo header here has a plus on the inside, so ground on the outside, so ground on the outside there. And I'm going to plug this back in. And if all has gone well, and we'll see if it has, when I power this back on, we'll hear both of the servos move. And when it happens, I'm just going to turn the power supply right back off again. It helps if all of the wires for the power supply are hooked up to the servos and to the board. I'll actually hook those up. And there we go. So I heard them both move and felt this one in my hand move. I don't know if you could hear them there, but they both will move to their center position as programmed. So that will be a useful thing as we try to align the various physical parts as we install them. At this point, I'm going to unplug those headers again and solder the LED wires into our board. This is the point where we need to know which of the wires coming off of our LED star is the positive lead, going to the positive terminal of that LED star. You can see one of the pads next to the LED indicator here has a plus sign, so a positive wire in there, negative wire in the other side. So I'm going to take my 2 wires here coming out of the prepared wires earlier and just strip them back a little bit. And this is the point where I'm actually going to even them up. Just going to snip them both so they're basically the same length. And strip a little off of one, strip a little off the other. Put the safety glasses back on. We'll thread the wire that's attached to the positive terminal through the plus-sided hole in the PCB. Actually trim this down a little bit, make it easier to thread. Chris says test LED before soldering. Yeah, that would be a good idea. You certainly could. I'm feeling brave. Ooh, am I feeling brave? I did say this was a second head LED. Chris, you've given me a crisis of confidence, but no, you're right. I should do that. Well, here, so I'm going to just before I hook my power supply back up, I'm just going to turn the current on it way down. So these LED stars, right, of course, don't have built-in ballast resistors, right? You have to figure out your own way of preventing them from going over current. And I'm just going to use my bench power supply for that purpose. So at some point, I turn the current limiting back up. We do not turn on. Isn't that interesting? Chris, I'm grateful to you. I probably should have done this before I soldered them onto the wires. Huh. That LED star is non-functional. Huh. Well, that's good to know. Thanks, Chris. 10 gold stars to Chris. Dave says, did I get red and black wire for Christmas? No, I'm still working through the spool of brown. Oh, wow. Well, Chris, thank you for that. Thank you for that check. Maybe I'll put that on my list of things to add to the instructions somewhere, is check LED. That would be nice. Well, let's see. Let's see what other options we have for LED emitters readily at hand. Here we go. It's actually, this one's got an older heatsink on it. Oh, I lifted the pad off of that one. That one's going to be a pain. This one is just bridged, but I think that'll be okay. So I have to go back a little bit. Thank you, Cookie. Thank you for dropping those 10 gold stars. Yes, Chris, Chris, you win. You win the star prize of this section. So, all right, so we'll take a little step back here. This is a good time for questions or, snack break if you're taking one, because I'm going to have to basically redo this part of the light. But at least it's now, not later. So I'm going to unthread the star from its sleeving. I can probably just reuse these wires. That'll make life a little easier. I'll just break that off, break that off. I'm going to take my flathead screwdriver and just use it to get the LED off of this heatsink. And I'm going to solder these wires on before I put it on the heatsink, because I've made that mistake before. Trying to solder the LED stars while they're on the heatsink is extra hard, because you have all that extra thermal mass working against you. And that's no fun at all. All right, here. We'll just use a little bit of this desoldering braid, this solder wick, to get rid of some of this excess solder from my previous excursions with this LED star. Oh, wait a minute. I don't remember which of these was the dead one and which of these was the one that was working. This must be the dead one. Well, I can find out really fast, can't I? Thomas makes a good point. Yes, the heatsink is doing its job if it's hard to solder to, because it's taking heat away. Here we go. Let's take some solder off of there. All right, now, I'll lose my own head. Okay, so current limiting down, pretty low. Hopefully we don't cook anything along the way. Let's see. Turn that really quite far down, and I guess I'll turn the voltage limit down too. Okay, so this is the good star, I think. No? Wait a minute. Wait a minute. What's happening here? Are they both bad? Or am I just doing a bad job of this? Might be. If this... there we go. Oh, I might just be... What is happening? You're not backwards, are you? Or all the way? Yeah, I'm not backward. Huh. My backup for this is I have a bunch of these little single LED stars. New in bag, as it were. Which maybe we'll just punt to that, because so one of the I don't know that I've mentioned, one of the really nice things about using a dimmer like the AL8860 is it is a current based LED dimmer, so it is basically whatever yeah, tummy cam and scalp cam can be friends. Whatever voltage you throw at them, their job is to basically ensure through buck action that the average current through your LED is what you tell it to be. Meaning that, this has a forward voltage of about 11 volts. This is a forward voltage of like 3.7 volts. But to the 8860, it doesn't matter. It just knows that this one, you send a pulse of current through it at, 15 volts. For a fairly high amperage, and then it's going to have to be off for a correspondingly long amount of time so that the average current through it remains, 1 amp or half an amp or whatever you set it to. So you can basically, interchange these LED stars really freely because your driver is basing its regulation on average current, not on time or voltage or anything else. I have to remember to turn my current limits down on this before I plug it back in, but I'm sure I will do that and not forget. All right, so turn my voltage down. Turn my other voltage down. Plug in my... I'm testing it now, Chris. I'm testing it now. I'll zoom me out because I seem to be flailing all over the place. We'll plug that in. There we go. That one works. That's still plenty bright, right? That's plenty bright, and that's 1/4 of an amp at 3 volts. So this is 750 milliwatts of light, and already, like, it's not unbright. Maybe, yeah. Anyway, so that'll be a fun way to go. So now we'll stick that on the heatsink. There we go. All right, now we have to sort of repeat some of the steps we did earlier. We'll... Excuse me. I need another questions break here soon, I think. I'm just gonna thread my wires back through the hole in the body of the light. I'm gonna thread them back through that sleeving. There we go, as they poked out the other end there. And now we will solder these of this working LED, thank you, Chris, onto our PCB. So we'll strip the ends off here again to make sure I can still tell which is positive here. Now that we've shaved a little bit off the end here, I'm just gonna take a moment and Dave, this is answer your question. This is my this is your answer to my red and black wire question. No, I'm still using a Sharpie and marking the brown wire. So we'll just strip just a tiny little bit of that wire off, and a tiny little bit of that wire off, and we will feed the one connected to the positive lead through, I guess did I solder that right? I did, that's a good sign. Positive lead goes through the hole next to the plus sign, just here, and other lead goes through the hole not next to the plus sign. There is no minus sign because it did not fit on the silk screen. Let's get in there. Oh, I pulled the first one out. Yes, you could certainly, if, I don't know actually, Chris, in the current configuration, if a JST board mount connector would fit on the board just here. It's this LED header is really close to the inductor. That's this big black part that's part of the LED dimming circuit. But you certainly could. If I were to ever, and I don't know if I would ever do this, but if I were to sell this thing as a kit of parts, right, with the PCB, with the surface mount parts pre-soldered, and you solder on the provided through-hole parts and put the thing together with your own 3D printed parts. You know, like, so I'm imagining it's the PCB with surface mount parts pre-installed, and then loose, you get the through-hole parts, you get the Phoenix connector, you get the servos, and you get an LED star with the product, like with the kit. Then yeah, then I think I'd put like some kind of JST or similar connector on, so it would just be a pluggable thing and not a solder in. So you could certainly swap them out in that way. Well, that step took just a little bit longer than intended, but that's all right. The next step, and I put it on here because it's an error I've made, is plug the servos back in. Don't forget, you'll have a bad time. So now we plug the servos back into our control board. And this, it may feel a little bit premature, but this is actually the easiest side to do it. The servo that is on the lid of our case will be our pan servo, and the servo that is in the head of the light will become our tilt servo, and those two positions are labeled on the PCB. Again, with the signal wire, you do usually the orange wire toward the center of the board. You can zoom back in a little bit now. Our next step is going to be install the PCB into the base print. And you'll recall that some time ago, here, actually going to advance a couple steps, install PCB. We'll install the PCB into our base print here. You'll recall a little while ago that I said to hold on to the second screw from the tilt servo because we were going to repurpose it, and this is its purpose. Just to make the hardware a little bit easier to manage and maintain, the circuit board is designed so that you reuse the unused screw from the tilt servo to install the PCB into the case. So I'm just going to pop out the pluggable part of the header here. Then I get the PCB down into the case. It should be obvious, the orientation, because there's this big wankin' hole in the side that allows the Phoenix connector to pop out. And then I find it easiest to use a little pair of tweezers. I have these nice hooky ones to you sort of align the PCB so that its singular large hole is above one of the pillars underneath it. You can sort of see it through there, or at least I can. Then put the screw down in there, take your pliers out, and then come in with your Phillips head screwdriver and screw down. There we go, screw, screw, screw. Here we go, it's biting, and I know you can't see this because my hands are in the way, but now I've got a single screw holding it in there, and that screw is right behind the point where the Phoenix connector is, just so that like any mechanical force you're putting on the connector is translated right to that screw. It does, you know, sometimes flop around a little bit in here, but once you've tightened that screw down, it's pretty rock solid, and certainly there's no mechanical action you can do here that's going to dislodge the circuit board. Our next step, and again, so I mentioned earlier a step that was like, you know, one of the kludgier parts of this build that I hope to improve later. Here's another one, and I just want to be totally candid about this because as you see better ways to do these things, I encourage you to, which is we're going to install the pan servo cover on top of our pan servo. So this is the pan servo cover part. It's going to sit over the pan servo just for aesthetics, just to hide that part. And for now, the recommended way to do that is with something sticky. Maybe it's, and I'm going to use some VHB tape here, some nice big foamy VHB tape. I've used sticky tack. You could use epoxy or something else. I don't know what. This is obviously like not ideal, although it does hold quite well. But something that was like a little bit more mechanical with like a tab and a lock might be a preferred solution. Ooh, yeah. So I do not have a JST crimper, but Thomas says he had a JST and a DuPont crimper kit. Yeah, it's a very worthwhile investment. I really like having DuPont crimps. DuPont connectors, everyone will know when you see them. If you don't, it's the connectors on your breadboarding wires. The 0.1 inch headers is a DuPont connector. You can get crimps in all various sizes with various numbers of pins and so on. Super useful to have around. I guess one of the reasons that I don't have a JST crimper, I've never bought one, is there are many flavors of JST, of course, and you'd want to pick one to standardize on, I imagine. Do you know what species of JST your kit came with, Thomas? Out of curiosity. All right, so now that's just VHB'd in place, right? It's not the classiest solution, but it's what we're working with for now. Yeah, JST XH. Okay, that makes some sense. So pan servo cover is attached. And now we install the case lid. So we did all of the cleanup that we in theory needed to do earlier. So now, in principle, we can sort of just fold our pan servo wires down into the base. And with this side that has the notch in it facing toward the notch of the cable management, we're going to lay our sort of cable guard into that other notch and slide our pan servo in. Sort of dress our cables as we go. And now things are really starting to come together. That's now the base of our light there with our pan servo poking out the top. Let's see here. Next step, we're really flying now. Well, this is good. This will take a little bit while. This will kill some momentum. Is installing the yoke onto the pan servo. And this is another one of those locations where the tolerances are deliberately tight and often quite a bit so. So I'm going to take out my round needle file from my needle file set. This, I think, was a Harbor Freight buy ages ago. It's a great little set of like 12 files, like a triangle one and a flat one. Oh, thank you for the menu update. Install lid, install LED. Did I do the install LED? Maybe did I skip a step? No, I think I just put the steps out of order. Yeah, mount LED will be next. So we'll do yoke first, and then I'm sure I will remember to go back, of course. So I'm just gonna test fit this onto the servo here, but I think it's gonna be too tight. Yeah, for sure. That's not unexpected. That happens every time here. This menu thing is fun. I'm clearly not remembering it well enough to like actually make solid use of it, although this is the first week that we're trying it. I imagine in some of the weeks where we like talk about, structured things and not just like lighting things on fire, which don't get me wrong, those are great weeks. But when we talk about like, how to do a thing, I feel like the menu structure might be useful, especially if you're watching after the fact. But I guess I have more to learn about how to train my muscle memory to actually update it in a proper time to make it useful. But it's kind of fun. It's a not that I use it for this purpose, but it's a tool that's meant for video game speedrunners to track like their progress through a speedrun of a game. But I've turned off all of the timing functionality and left all the menuing. So it's just like, it thinks that I'm taking an awfully long time on this yoke split of the Demilight version 0.9.4 video game. Certainly not my best. Still a little bit tight there. Do a little more filing. Like I said, this is with these prints and my printer, I'm not at all surprised that it's this much. When you come to install the pan servo, so you'll remember that we centered our servos back in a previous step. So right now, so wherever the servo is now is going to be center. So I often like the head of my light to be pointing away from my Phoenix connector, which means because the yoke goes into the left-hand side of the light, that I'm going to mount the servo here so that that center is pointing this way. I have 90 degrees left and I have 90 degrees right. So it's going to sort of face off to the left side of the light here when the Phoenix connector is toward me. That's a decent fit. You want it to be able to basically stay on the servo rotation part without a screw, and the screw will just help it along there. So I'm going to put that little tiny servo screw down in there. Not too tight, just tight enough. And so when you rotate it, you should be able to feel the servo rotating with you, and it's not slipping on that servo horn. Let's see, I'm going to test my range of motion. Something's gone wrong. Looks like centered is actually here. So that's a good thing to check now, right? So I can sort of loosen this screw, take the servo off, take the yoke off. Should go back and make sure there's not an issue in the code that was doing that centering. Just attach that again, and now full left and full right. Yeah, there we go. Time for a Demilight speed build? Well, given how this one is going, I mean, maybe. Hopefully they will get faster than this. But we'll see. Now before we can mount the head, we finally have to attach the LED star itself into the main body component here. Here's another kludgy step. This one's actually a little bit more deliberately kludgy. Again, I'm just going to use some foam VHB tape. And that's because, part of the goal of this project is to be relatively LED star agnostic, as evidenced by the fact that I am, we started with one, it didn't work, and I'm going to switch to another. So using an adhesive solution, means you can kind of just shove in here whatever you want. I haven't found a huge difference. So that VHB is sitting right up against the back of our heatsink there. Just based on when the solder releases from the LED star, I haven't seen a huge difference in heat management between the heatsink with tape on it and the heatsink without. It doesn't make it. I mean, it does make some difference, but not an enormous one. So I feel okay about the solution. If this was ever going to become like a manufactured thing or a kit thing where we standardized on one star and one heatsink, then this would probably become part of the 3D printed processes. Some additional bracketry in here to mount this. For now, if you're building it yourself with your own choice of star, you can just stick it in there. I love this foam VHB, by the way, the gray foam VHB. Very useful. Now we mount the head onto the yoke. Gotta update the thing. Oh, we're back and we installed the LED. Now we do the yoke. We'll mount the head onto the yoke here. And then once again, this should have been centered in a previous step. I suppose we'll find out in a moment if it wasn't. I like my lights to be, so they're gonna have 180 degrees of tilt, and I like them to have that around a roughly 45-degree forward angle. So I get 45 degrees down and 45 degrees sort of back, sort of over tilt, if you will. But again, I think I'm going to have to do some... Oh, yeah, good. You were hoping there was going to be more filing. I could tell. So there is. Maybe I'll hydrate here before I dive into filing part 2. Stand. All right, so let's... Where were we? Here we were. We were filing. And we're unmuted. Had a good run tonight. Ow. Just some filing, Maybe this is the ASMR. Let's see. Thomas says, will the head collide with the base if you have the center too low? Yes, it definitely will. So if you centered it up so that your center was here, say, yeah, it will collide just there. So you don't want to have your center probably any lower than I'm going to, right? Because I'm going to do 45 here, so that its lowest is approximately there. But any more forward than that, it will collide. If you want to make a version with a taller yoke that wasn't an issue, I would love to see it. Thomas, are you still doing... You were doing things with, like, commutators and slip rings at one point, yeah? Being all fancy. Let's see here. Let's see if we'll just do a little test fit. Yeah, still a little tight. Especially on the... What is the... upper surface of what on my print is. It's on the bed. I get this little nubbin inside this ring. It happens on every single print. It's just a byproduct of how my machine handles bridging, and so trying to file that out while not while keeping the roundness of the circle there of the servo interface is just a little bit tricky for me. Yeah, still too small. Yeah, Cookie's gonna do a mover as well. Awesome. Maybe we'll all get a booth at LDI when LDI is a thing again, and we can all be a little tiny booth. We can have a little tiny light show all together. That'd be a lot of fun. All right, come on, part. I'm gonna file you out. I'll make you fit. All right, let's see here. Oh, we're close. We're close. Cookie says down. Up. Left, right, left, right. Let's see here. Oh, down as in down for that. I see. Yeah, that makes sense. Yeah, that'd be a fun time. Yeah, because I feel like, I mean, like, there's not really an end purpose to this, as you've certainly gleaned. It's just kind of a fun thing. But as I think about, if this was going to be actually useful for someone, having, 20 of these 20 little lights of any stripe hung up on a little tiny grid, and you have, a classroom-sized light lab that's DMX controllable, right? Is a cool thing. Or, I mean, in the world of remote learning that we're all in right now, like having a light lab that you could have in your home or your dorm or something seems appealing. We're a little late to the party for that, I think, hopefully, as things are getting better slowly. There's a light at the end of the tunnel, I think, is a safe thing to say. But that, LDI or USITT or any of those conferences that focus on lighting technology might be a fun place to get people into things. Let's see here. All right, so I think this is going to be good enough. People will always want fun stuff. There's a moving light at the end of the tunnel. Yes, it's true, because it's a light at the end of the tunnel, but it seems it's moving closer and farther and closer. Ugh. All right, yeah, that's a decent fit. So now, again, I want to make sure when I move the head by hand, I can feel the servo moving and it's not slipping. But again, the centering is wrong, right? That's the extent of my travel, so center is actually here. So a good thing to check as you go. Yeah, maybe I don't know. I'll go back and look at the code and make sure it did what I intended it to do. Put that in center position here. This may not behave exactly like the other lights I have. I don't remember I haven't really standardized on like where the center of them is. I think this previous one centers straight up, but it doesn't really matter of choice. This one also has a different LED star. They're kind of customizable. And then I think we're on to the very final step, which is install the other half of the head. So our final 3D printed part, which is the right-hand half of the head, just has these tabs, and that will just slot down in to the other part. And it's deliberately a pretty tight fit with the LED stars. You may have to fudge them in just a little bit. Because again, this is just a friction fit. There's no actual mechanical interlock there. There we go. And now, that's our complete little tiny moving light. Shall we see if it works? I'd like to. And it might not, and if not, we'll troubleshoot it a bit and see what went wrong. Wouldn't that be anyway? If I was being, careful, I would say I'll test it off camera. But careful is not what we're here for. We're here for fire. Just gonna use a little bit of sticky tack to stick that down, just so it stays there. And let's see. Dun, dun, dun. All right, let me turn my power supply off. Turn the power supply on, I guess. Turn the voltage back up. So in terms of power supply voltage, right, the AL8860 LED driver is a buck converter driver. So to turn your LEDs on, your supply voltage must be higher than your LED's forward voltage. So if you have an LED start with a forward voltage of 11 volts, say, you need a 12 volt or more power supply. Well, I hope this works. Yeah, look at that. So remember, these are both addressed at 4, so they're doing the same moves at the same time. Looks like this one's having tilt servo issues. Ooh, yeah, something's binding in the yoke of this one. Like I've over-tightened that yoke a little bit. But yeah, so that is the process of assembling the Demilight version 0.9.4 tiny moving light. Oh, I'm so delighted. It worked first time. That's also kind of unique around here. But this is great. And you can see, so those are running at the same intensity. This is a 3 LED cool white star. This is a 1 LED warm white star. And it's hard to tell how much this is showing up on camera. This one is less bright, for sure. But as we learned a couple of weeks ago, a month ago, we can't really run these chips at full power for very long anyway because the solder starts to melt off. The maximum power we can get out of one of these chips before normal temp, leaded solder starts to melt was about 5 watts, even with the heatsink. And if you put an amp through this, you'd get about 3.5 watts. So your maximum brightness on this would be like 65-ish% of the maximum brightness you'd get out of one of these. These are both running at like 5 and 10% right now, so they don't blind me. So going to these like 1 LED stars is a decrease in brightness, but not a terrible amount. So that was a good punt for demonstration purposes tonight, I think. Also, the reason that this one is freaking out is because the transmission of the NeoPixel data is not synchronized with the DMX reception interrupt. And so when the NeoPixel data starts going out, it occasionally will interrupt its reception of a DMX signal. And that's when you see it freak out for a second and catch up to itself. Sort of intermittently, depending on how frequently it's sending out that NeoPixel color data. But yeah, that's the gist of it. That's assembling Demilight version 0.9.4. And like I say, obviously there's some kludgy parts. There's some parts that are literally held together with like adhesive and hope. So I say take the files and do fun things with them. And enjoy, build stuff on your own, and as always, send me questions, right? Find Twitter is the place where I'm like most likely to respond in the moment, right? So at Jeffers Glass, always feel free to call my shop phone. It's set up so you can't ring it late at night or early in the morning. So there is a voicemail if you want to ever leave me a voicemail. If you prefer to leave me a voicemail, call between 10 p.m. and 8 a.m. Central Standard Time, and you won't get me. But yeah, it's a lot of fun. Yeah, and there's also, you can if you prefer an email, if you email me at demilight@jeff.glass, that will find my way to my inbox, and I'm happy to answer anything there. Yeah, and Chris, I think your idea of like doing a introduction to how you would get these PCBs ordered would be a fun thing and probably a valuable thing for folks. Maybe that'll be a fun thing to do in the future. These will all continue to be updated. Version 0.9.5 is on its way from the assembly house to me currently for testing and verification, and then that will be that. So speaking of, let's talk just a little bit about next steps and some of the things I have been teasing about all evening and where this project is going. So let's see here. There are a few changes I want to make to the Demilight project, especially on the PCB. I'm going to steal this other one here for now. I've mentioned a couple of them already. One of them is going to be serial programming instead of programming via the ISP header. And actually, maybe it would be more interesting to just pull up Eagle and show you the PCB design for version 0.9.5. We can talk about that together. Chris says, does that mean version 1 drops in the first quarter of 2021? I don't want to commit to any firm deadlines at this point, let's say. Also because, I mean, partly I have quite a bit of time with how my work schedule has worked out at the moment, and that's going to become less in February, so we'll see how that ends up playing out. But version 0.9.5, if we can see that there, let's open the schematic, bring the schematic into the correct window, and look at the board. There we go. So let's look especially, so the version 0.9.5 PCB looks a lot like version 0.9.4. The major differences are, you'll notice over here on this side where our ISP header was, we now have a 6-pin programming header that matches an Arduino Pro Mini, right? So instead of using an ISP programmer, you would come down into your Demilight and just plug in one of these cheapies and program it that way over the serial port. Hopefully that's easier for folks to get their hands on. There's also a few additional I/O lines broken out to various through-hole pads. So you get a 5-volt pad, a ground pad, A0 and A1, a few digital lines. I think they're notated more clearly on the bottom. D7, D8, D9. You still have, so this is going to be the ISP header that I would use to burn the bootloader onto it. So you get your reset line and 3 I/O lines there as SMD pads, and D2 as well, just to give some more opportunities for having using this board for other things besides just this like little tiny Demilight board. You may have noticed here, I'm using another one of these 0.94 boards as my controller. This was actually what was running the ballyhoo that these lights were running. I just configured it with a different bit of code to make this a DMX transmitter instead of a receiver. And so that's a cool bit of functionality, but if I had 4 or 5 I/O lines and could put a couple buttons on this thing, right now the possibilities start to open up a little bit more. Not so far as like, there is a world in which like there's a whole separate project which has all of the I/O broken out, so you could say attach a bunch of potentiometers to it and make your own DMX controller and so on. That's not sort of the goal of the additional I/O. It's just to give you, since we're fabbing these boards anyway, might as well break out the I/O to a few other things, a few available pads, just so you can add some additional functionality if you want to, right? That's the goal there. That was the I/O access step, he said, remembering to update the header. RDM, yes, is another big step, and like this is what I've been teasing this whole time, and Thomas kind of got it earlier. And I think I've mentioned before, I would really like these tiny lights to be addressable via remote device management protocol, so you could plug them into an actual DMX node or other device and address them via the DMX line and not have to get into the light at all to address them. Some decent progress there recently, not as much as I would have liked because I've been working on, as I said, on documentation. But just in the mail today, I got one of these guys. This is a Yarilo DMX Pro. It's a lot like an Entech old DMX Pro product. That's a DMX and RDM interface for the computers. Literally, I took this out of the box like I get 2 hours before we started tonight. So I'm hoping to use that as an RDM testing tool to validate my RDM device code. Until now, I've been having to write device code and controller code at the same time and kind of use them to test each other. Now I have sort of an off-the-shelf RDM device to play with. That'll be helpful in the pursuit of getting these devices to talk RDM device code. So I think that'll be a lot of fun. The other thing that I'm super excited about that came today, literally hours ago in the mail, is these little tiny cases from our connector. They're from AliExpress, right? They're meant for you to fabricate your own what have you barrel, right? It could be anything with this D-shell connector sort of form factor. So XLR, PowerCon, True One, anything like that, you build your own little barrel. And this was like, I think $1. You get them for cheaper if you bought them in bigger quantity. I bought like 5 just to see if they were worth it, and they are. They're really nice and durable plastic. They're pretty rigid. And I also got myself a bunch of these little 5-pin XLR D-shell faceplates here. So the idea with this project, this is very early on. This is the programmer that Thomas was referencing, is right? It's all well and good to be able to address these over RDM, but most people, myself included until a few hours ago, do not have access to an RDM programming tool either. And that is true of both like home hobbyists like ourselves and theatrical electricians. Like when I was a master electrician at a big old regional theater, it was not other than hooking my laptop up to our Net3 system and using ETC's, $2,000 Net3 nodes that were plugged into all of our lights to address things. RDM was not that accessible. So here's what I'm thinking. A form factor much like this one, a 5-pin XLR, female jack on one side. On the other side, you can get, and I have gotten, and let me see if they're just here, yeah. You can get blank face covers if you want to, right? You can just sort of cap this off like you would in a rack. But what I'm going to do is have a PCB manufactured as part of this process that fits this form factor exactly with 2 screw holes here, into which the board house will route for me the holes for an interface. Let's see if I can load this up. I'll close this board, we'll close this schematic, and we will open the microcontrol project. It's going to be a little bit hard to see. So this is actually would be the interior control board as opposed to what you'd see on the outside. But you'd have a little tiny interface. So this circuit that you're seeing on screen would be the size of this form factor. So it's like 27 millimeters by 25 or something really tiny. You get a little 3-digit 7-segment display and 2 buttons, right? And all that this device would be meant to do is you would hook it up to your DMX chain or your singular light somewhere in your system. It would have, you turn it on by pressing either button to have some kind of small internal battery. And this goes back to, I'm going to learn about LiPos or other kind of battery power to do this. Its default is has a setting where you tell it to discover via RDM all the RDM discoverable lights on your chain, and then you can iterate through them and address them one by one using the 2-button interface. And I've worked out a control scheme that I think will be relatively cromulent, and if I can find it in 5 seconds, I will show it. I put it on Twitter the other day. I don't know if I can find it right off the top of my head. I think I did it from my iPad, but so a little tiny pocket DMX addressing device is as one next phase of this project. And would this device do other things? Like, would it control personalities? Would it give you errors? I don't know. The limits in display size here are really minimal. But it would be a cool testing ground for like RDM controller code. And once that was in the bag, it would be cool to expand that out to like a slightly larger desktop tool that they would probably either hook up to your computer or have a larger display where you could, if you were working in your light shop and you need to address 10 lights, you plonk this thing down, and rather than going through the menus on all of the lights, you say, okay, discover all my lights. Okay, identify, the first light you think is first. Okay, that one, that's address 10. And that one, that's address 12. And that one, that's address 13, and whatever it is. So I don't know, I'm jazzed about the form factor of these. I think it's really cool. I think it's going to be an exercise in miniaturization, and I'm excited to learn more about battery and charging technology to do it, and also to like fabricate a faceplate out of PCB idea. I think it's going to be really slick and also a little bit challenging. So I'm excited about that. And then the last thing, and this is a little tiny thing that we maybe will iterate on. We played around with color on these Demilights last time around, I think 2 times ago. I don't remember. Maybe it was last time we did Demilight stuff. And I think that would be a fun thing to fold in. I have not put that code up anywhere because there is this issue where the NeoPixel data and the DMX library interfere with each other some, and that should get sorted out. But when it does, I want to roll that into the Demilight project as well, because I think that's really evocative for people to have color options in their tiny little lights. And that's it. Could 3D print a cover over the PCB as well? You certainly could. Oh, so just to be clear, what I'm imagining is this is actually a 2 PCB solution, right? So there would be a singular PCB which actually had no components on it. It's just milled FR4 with labels on it. And then behind that would sit the PCB, would sit this control PCB with these buttons and this display, sitting just proud of the surface. So the display would be just flush to it and the buttons would poke through a little bit. And one of the nice things about doing it as PCB is we could do something like, send it to the board house as a single PCB but connect it with mouse bites here with 2 little breakaway tabs, have them fabricate it as one big piece, and then whenever you order this whole PCB, you're actually getting 1 PCB with components and 1 PCB that is just a faceplate. And probably there will need to be some additional, there will have to be some actual brains inside the thing, and so probably that would be a 3rd tiny PCB that would live down in the center of the thing here, that would also be connected to the other 2 PCBs via mouse bites. So you order this 1 PCB, which is actually 3 PCBs with breakaway tabs that then become the back cover, the back display, and the main processor. That's the theory. There's a lot of in theory that works there. There's also like it's small, right? The whole thing is, I think, 60 millimeters end to end. So it's tight, and you can see, I don't know if you can see already, but that takes up a non-trivial amount of space in there. So there's some things to be navigated around. How do we fit a really tiny battery in here? There's a little tiny rechargeable LiPo. Do AAAs fit? I don't know. I'm a little nervous about the LiPos myself, but that's maybe just a challenge to be overcome. Maybe the LiPo fits along the side here. I don't know. Thanks, Cookie. Yeah, I'm excited about it too. There's just something about like this form factor that feels like when I was a full-time master electrician, I would have loved to have had something like this. And if I can, make it durable enough and inexpensive enough, I think that'd be a cool thing to get out into the world for people to use, and to use RDM more in their projects. Chris, this let me just find the AliExpress listing and I'll just show you what it's called. Let's see. AliExpress. Here, I'll tell you what. You don't get to look at my screen while I log in. What do you get to look at? You get to look at here. You can look at the pretty table while I log into my account. I'll just pull this product up for you. We will sign in. Dave, CR2032, interesting option. There's just not a lot of power capacity in them. I'd worry about it dying too quickly, especially because the displays take not a ton of power, but a non-trivial amount. It's not a crazy idea though. Maybe that's worth looking into. How much current capacity? I want to say it's like 140 milliamps in one of those, which might be enough for like a practical amount of usage, because it basically would wake up on button press, and then after, I don't know, 60 seconds of an activity, it would go back into deep sleep, I imagine. Let's see. I'm having my AliExpress on my computer is throwing up on me just a little bit here, so I'm gonna find it's not interesting streaming, I swear. I'm just gonna find the product. I know it's logged in on my phone. I'm gonna look up the order there, find the search terms, and I can show it to y'all. Because when I saw this part and this form factor, I got excited. So yeah, happy to share it. Let me just pull it up here. Let me see, what's the best way to do this? Let's just go back to AliExpress and high power speaker coupler case. Let's see if that gets me. Yeah. So this high power speaker coupler case got me to where I was going. Now the labeling on mine does not quite match. These are labeled like PowerCon. Mine is labeled R connector, but it's one of these. Yeah. So here you can see like single piece, 56 cents. 50 pieces for $36. That's worse, isn't it? This is on sale. Well, that doesn't make any sense either. 68 cents unit, but they're on sale for 56 cents right now. Yeah, super, super interesting, right? And you can get these D-shaped connectors in anything you want. Like if you wanted, let's see, can I get quarter? You can get certainly any flavor of XLR. You can get PowerCon. You can get 1/4 inch. You can get 1/8 inch if you look really hard. You can get blank covers, true one. So this would be a fun way to think about like how could you what could you use these little boxes for, because they are really dirt cheap. I kind of like these for like other things too, like this with just a couple of blank plates on the end. Right, and these blank plates, I mean, these are metal. These are the nice ones, which I did not realize I was ordering at the time, but here we are. Come with some nice little metal mounting screws, right? That's kind of a neat project box form factor for things, right? Even if it wasn't coupler related, right? You shove a little, honestly, I'll bet a Pro Mini fits in here, especially if it didn't have headers. Here. Yeah, right? So especially if you didn't mount the headers on that, now you shove that in there, you look at like a 2032 situation there, Dave, or a 9-volt battery would fit, but it wouldn't leave you a ton of room, although I bet you could fit a 9-volt battery and a Pro Mini that didn't have headers on it in there, just by eye. You could sort of stack on top of each other. Maybe not with connectors at both ends. I have maybe 3/8 of an inch left once that Pro Mini is sitting in the center. But anyway, now I'm just rambling, because yeah, it's robust, it's cheap, and it's small. Like, this is what I think of, that's pocket size, right? That's very comfortable to fit in a pocket and pull out and use and toss around or throw in a toolbox. So yeah, I'm stoked. We'll see how long it takes to actually get that going, because, you know, there's like 70 things I want to do, but I think this is a fun one. So yeah, yeah, way cheaper than Neutrik. I mean, anything's cheaper than Neutrik, Chris. Diamonds are cheaper than Neutrik. Well, on that note, y'all, this has been a great time. I'm glad that the thing, other than the LED not working that we plugged in, thank you, Chris, for catching that, though we needed to test that before we trusted it. That's how you assemble a Demilight version 0.9.4. And go check out the files if you're interested in them, and let me know what you think and what I've missed. I mean, we found a few things tonight. And if you do things with them, if you print them, if you try them, if you think that they're awful, I want to hear about it. Send me pictures, send me thoughts and comments, and do fun things. Because, yeah, it's fun. Like I say, there's no real end goal to this. It's just kind of fun to put these out into the world. So it was a ton of work to put the documentation together, but I think it will serve me well going into the future. And it was a good process to, like, think through what the actual assembly of one of these things looks like when you put it down on paper. So yeah, it was a fun process. It felt official in a way. We'll see what all the problems are in that instructions as people go out into the world and build them. With that, I just want to say thank you. Thank you for hanging out with me here. Thank you, Cookie and Dave and Thomas and should I say Chris? And I don't know. I'm losing it a little bit here at the end of the night. It's been quite the week. But yeah, thank you, everyone. And everyone out there who is just hanging out in the background and watching later on YouTube. Y'all are great. Thank you for, I know, your enthusiasm. Thank you, Nate. Oh, hi, Nate. Yes, of course. Yeah, your enthusiasm and your interest, like, really, it makes this a lot more fun. So thank you for that. Stay safe out there. Wash your hands. Wear a mask. There's a moving light at the end of the tunnel, as Thomas says. Please be good to each other. Please do good things in the world. Please be good to yourselves. And I will see you next week for more shenanigans.